In a world that walks the line, there's a rare few who think outside the box together form the crew to break the equations, not bound to any rule, exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tones from the prongs. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills.
Hey everybody, welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
Hey, Nathan. What's going on, everybody? TGIF, motherfuckers.
Oh, man. Good Friday, bro. We're doing good work today.
That was a couple of months ago.
We're on Energy Exchange today, Joe.
Right on, man.
I want to show you something.
Topic, that we've been talking about. It keeps on reoccurring.
Oh, yeah. I want to show you something first. Joe caught me building something in the background. Check it out. So this right here, it's the pillar for all of the hardware we got going on for the Arduino thing. Okay, all the stuff Lightspeed sent us. I'm reformatting everything. So I want you to notice all these right here. They now plug in. So every sensor now is pull in and pull out, dude. So go to the wires, get right next to the machine, whatever you got to do. If it breaks, pull it out, replace it. You know what I mean? Every single one of them all the way around. Camera sits up here, man. Use the light. Took care of it. Goes in there. We're set, brother. We got something cool going on. So, all right. I just want to get that out of the way. Show everybody it looks cool as hell. All right, man. Energy exchange. Let's get into it, Joe.
So, we've been talking about this for a while, and it just keeps on reoccurring. And it's like, no matter where we look, there's the energy exchange. And, it kind of occurred to me that, we keep on talking about this thing, but we've never actually dialed in on what this energy exchange even is. Because if it's reoccurring and kind of all works the same, then, well, what is the same? What is it doing? How does it work? Why is it doing it? Like all these interesting questions that they kind of get risen up out of it. And, it really is the basis of all the phenomena that you see when you look up into the sky, when you look down through a microscope, when you're trying to create something. It's just the natural order that everything falls into because it's all a part of the same system.
Yeah. Well, that's what we show when we show Sean's Rav experiment, man. That
Fun example.
Yeah, pulls into equilibrium quick. Crazy thing is, man, energy exchange, I don't think people understand that. They see math and they see equals and they don't understand, you know what I mean, that it's equilibrium, and only in an equilibrium do you get an energy exchange. You kind of miss the point with the math, you know what I mean? In order to get there, it hides it.
Well, it's actually funny because, I guess spoiler, rather than build up to drum roll and being like, that means it's, I'll just say it right off. It's entropic. It's all entropy, right?
Yeah.
And what it comes down to is when you have the combination of multiple entropic systems that are in interaction and therefore exchange with one another. It's sort of like the idea of taking two circuits, and then having them intertwined with one another, because it's the two circuits individually, but then the one that they create cumulatively, and that's sort of the idea here. And we obviously know that it has to do with entropy because, as we've discussed with Rav before, the whole entire nature of Rav is breaking the material down into its smallest parts, separating the charge differentials, and then asymmetrically exchanging through this energy exchange process between the material and the energy.
Mhm.
And then we had talked about exchange rates before, and I wrote a whole entire physics paper on the exchange rates. And once you realize what the RAV is doing, right, by taking the electrons, separating them out from the neutrons and stuff like that, those electrons represent the pure energy state, whereas your protons are actually the low energy state. They're the opposite.
I don't know
Um,
if they're electrons. I think they're ions, Joe.
well, I mean, it's all ionization. Yeah, ions. Sure, you could put it that way. Charged particles, right? That's how we like to put it.
Yeah.
Charged particles. Well, and this is what you end up with is a material side and an energy side separate of one another. Then you could sit there and bring them back and exchange it with one another for recombination. And this is the whole entire idea. This is what's going on at every level of the universe.
Yeah. Well, I think we lose entropy because of the way we set the anode and cathode. We don't realize that that's what it's doing, going to the top and bottom of this thing. So you got to realize the anode, when you put it in there, you get an energy, right? And sometimes it goes hotter, but the cathode's always cold. Every time we've turned this thing off, it's cold, right? But that means there has to be a cold side to it at all times. So the cathode side's always cold. The anode side heats up a little bit, and you start to see yellow, which is a very small amount of heat considering the energy that you're putting into this, right? So I think that's where entropy comes in. You're doing a heat exchange. You don't realize it right away, but that's
Mhm.
exactly what's going on in the anode cathode. But we usually see the outside, and we talk about the energy over here in the black dot and energy in the plasma, and they figure eight to exchange. Each one gets what it needs, but it's the entropy that causes it. So when you see the Earth and you see the field like this in the donut, the entropy is going through the center of it. I mean, that's what's causing it. So when we do it in coils, it vortexes the top, vortexes the bottom in reverse, but then the planet does the same thing. So when we look at the winds go one way, the winds go the other way, and we're naturally seeing it. We're not putting it together exactly the way we need to, but that's what's going on. If without entropy, none of this works. So when you start stripping back all the names of physics and everything into it, you start to realize there's a simple mechanical process going on here, not some crazy different names, you know what I mean, bosons, whatever. It's simple understanding. There's a simple math formula going on, and entropy has to be part of it. That's why I have problems when they talk about magnets and they talk about Faraday and stuff. Faraday did measurements on a ball, okay? And then all of the math is written in a linear equation. Well, you can't do that because you're missing the point. You're missing what they're seeing. And I think it's a huge failure. That's why the people still believe that the magnetic field goes around in this round circle when it's incapable of doing so. It just can't, because that means there's no movement. There's no energy without movement. It doesn't work.
So this is where the movements derive from, and I think the perfect way to understand it at all levels is if you think about weather, right? You have these high pressure systems that generally dominate, and then you have low pressure troughs that are created. And what you have to realize is that every grain of sand that's removed, okay, leaves a void in its place, right? So, the grain of sand falls away. Now it's empty, but another grain of sand has to fall to fill it. And that's exactly what's always happening. You always have the high pressure trying to rush in to fill and equalize the low pressure system. But then all that does is then, you know, create dissonance during that event, which we see as oftentimes storms, right?
Mhm.
And then as a byproduct of that dissonance, it creates another void where it's now a low pressure system, somewhere behind it.
Yeah.
And it's just the ever repeating cycle of that. So it's the chase, right? And we've said this before, it's the chase. So when you have these systems that are trying to come and fill each other, aka entropy, aka diffusion. They're trying to diffuse with one another to reach a state of equilibrium. Well, what happens when they're pushed away from each other, but then have to cycle back because they're trying to fill each other, but then they come and then they're pushed away, and then they come and then they're attracted again because they're trying to fill that gap. It reaches a new form of non-equilibrium stability, right? So it's never achieving the equilibrium because it's never truly in this mixed homogeneous state. It's always in this state of motion.
It reminds me of the Lorentz force and the way that it looks when you map it out. That's what it kind of reminded me of. It goes in and then immediately pulls back out, but it almost looks like an 8, you know what I mean? But then it comes into a different area.
Yeah. It's the repeating cycle that we see everywhere. It's exactly what it is, man. It's how everything gets locked into place. It's how accumulation occurs.
Yeah.
You
I
know?
don't think people realize, Joe, that we have vortexes that go on all the time. So if you've ever seen a map when they talk about weather and stuff and there's no storm going on, you start looking at it and you go, oh, look it over by the Keys, right? There's this little vortex going on right there. We don't pay no mind to it, right? You start seeing it everywhere and you realize when you get up in the upper atmosphere, that vortex is going the other way and it's going up, right? It's trying to penetrate the sheath zones. It's trying to give it a way to push through it. So when we saw the RAV and we saw the satellite and we saw the main one, it's big, right? And then you see the satellite is small, right? Then you start to understand the energy inside of it. This energy goes inside here, then it goes in the small one. They're equal in energy, right? But the size is completely different. What did you call that again, Joe?
Asymmetric exchange,
There you go.
or,
Banana.
offset equilibrium.
There you go. So
Both sides.
that's what I don't think people understand goes on in the earth all the time. We're seeing it, we're not paying attention to it, and because of that, it's setting off what we're thinking is happening.
Yeah,
So,
and there's this other concept that comes in about this asymmetric exchange, right? It's sort of like if you're exchanging bowling balls, right? If you have a 16-pound bowling ball and you're trading for a 16-pound bowling ball, and that's the exchange, right? It's 1-to-1. But what you end up with more times than not is not that. It's you exchanging a 16-pound bowling ball for a 10-pound bowling ball, and that's where the stability is reached because what it becomes a density type of circumstance at that point where the 10-pound bowling ball and the 16-pound bowling ball may well be the same size, or the 10-pound bowling ball may be bigger, let's say, right? So that's the offset. You have something bigger at 10 pounds and something smaller at 16, and because of the difference in volume to mass, that ratio is offset, and then that becomes an even in what would be considered an asymmetric but even exchange. And what's interesting about it is it's exactly what we see over and over and time again. That's exactly what that offset differential is. And this is why I said all along that one of the main components, the critical component of a RAV setup, okay, is always a higher density, lower potential anode, and a lower potential a higher potential, lower density cathode. You see that's how that's inverse. You're trading the concentrated power with a lower overall power, for a higher overall power that's less concentrated at the point of interaction. That's what allows for that exchange rate to occur when you put something that's that acts as a resistor in between, because as something that's insulative is only insulative to a point. you know, to which point it's not. You know, and once you start having these higher energy levels, you have a high energy potential saturating it from the bottom, but then you have the opposite, literally blasting it from the top. Those are the exact conditions that you need to take an insulator and turn it semiconductive, that then naturally allows for the exchange rate to fall into the correct ratio with the you know, concentrated energy on one side and the diffuse energy on the other.
Yeah, you know, one of the things that I found really cool about the Rab Joe is when it shows itself, and it's kind of a misunderstanding in the way people understand stuff. Light isn't the higher state of energy. And I know that's what the way they say it, right? But it's the energy that expels out. It's the loss. The higher state of energy doesn't have loss. And you got to understand that in that way, because it seems like when things light up, oh my God, there's so much energy there, right? But it's just the opposite when it's hidden and you can't see it. So when we saw the Rab burst out, right, and you see the geometric pattern in light, you know that the energy's there, right? But it's bursting out. So it's at a loss. It's now losing energy to heat and everything to the atmosphere. As soon as it goes back, it goes dark. You see, and then that's where the higher state of energy is, right there in the dark. So you think of it in this way. Is the energy all light? No, but it's a high energy vacuum that's going on that swirls inside there that make those things. And only when you see it, it shows up as light. And then boom, back to the dark. So when we see this thing and we take away, I showed this a while back, when you take away the background and stuff, you can actually see what Joe said before. The energy comes down, hits a part of a teardrop, and then folds back over, okay, to the other side and then goes back up. And it looks like a teardrop in the bottom, right? But that's exactly what's going on. But in that stage, you see it pop out, the little dots come out, and you see them all bright, and then they go back to a very dark state. You don't ever see them again, okay? That's the higher state of energy. So when you see an energy exchange that's dark on one side and plasma on the other, everybody think, oh man, the energy's in the plasma. No. The energy's in the dark side. You see, when everything shuts off and you lose your equilibrium, so you lose the center part here where you say the Rav is, and you have the dark part and the plasma part, what happens is, as these two, as the plasma part busts out and bursts like a sun would, it'll take in that plasma part, right? But that leaves the other side in a bad exchange. It now needs to take in everything from the sun part and the plasma part and pull it to it because it's now in non-equilibrium. It wants to get back to equilibrium. So now it pulls it in. Now you got a black hole situation going on. It's sucking in all available light.
So that was always the weird question. It's what I said from the beginning. And Nathan was like, when I first said this, Nathan was like, dude, what are you like? No. I said, where does the Rav go when you turn it off? Where does the Rav go when you turn it off? Does it go anywhere, or is it just waiting for the conditions to come back to re-arrive? You see, and that's the interesting thing. You see, the conditions tend to be because of how we have set up, you know, a power input from two different spots. Okay, fine. So you could talk the mechanism up as well. Obviously, it only goes on when the power's on. Yeah, but the thing is that there's like a point of return where it's because the conditions are set and that memory is there, that it actually doesn't really leave at all. It's just that the conditions are not there. And why is that? It's because of two things. When it's directly with what Nathan just said, your little dark zone over there, that's the high energy state, but it's not high energy density, it's high energy potential. Okay, and what you have on the other side is high energy density in the Rav. And, you know, as I proposed, and again, I know that this is speculative, it's not proven scientifically, but if you consider that heat is the signature of energy returning matter to an energetic state through this interdimensional or upper dimensional exchange, you know, it makes total sense why you have a hot spot on one side and a cold spot on the other, high energy that you would perceive on one, but even higher energy that you don't perceive right on the other in a state of potential. So what do you have to do to be able to get into that high energy potential state that's sitting off to the side? Well, vector it. That's what you have to do, is you have to provide a current vector to the high energy potential state. And if you could do that through a conductive material, well, that's all you really need to do.
Well, it kind of naturally changes in the exchange as you change the frequency that goes on inside of it. It forces it to change a little bit. And we see that when this thing goes on, you'll see it go not really bright at all, like where you can see it here, and then it goes down to almost nothing where you can't see it. So it goes hidden in the background, basically just like energy all around us. If you walk outside, you don't see the energy, but it's all around you. That's kind of the thing there. So it'll hide, you change the frequency, you amplify it. You know what I mean? You get the things to resonate better together. Boom, this thing appears beautifully.
See, they missed the point when they said that you can't have a closed system, right? Because you can't. But you can have two open systems that combine together in an exchange that have a closed internal loop. You see, and that's the part that it's all missing. And when we had originally proposed all of this Graviflyer stuff, and we were talking about what it would take to get it to self-power, right? And what it would take to have everything on board, the circuit that we were talking about always contained what? Multiple battery cells. And it had to, because it needed multiple places for these energy exchanges to come from to start the initial process. And then any overage that was created as a result of the constructive interference was supposed to be put back into the third battery set that then feeds back into the second battery sets. That was always, and this was old school talk. This was like Joe, Gerald, and Nathan sitting there like literally in total disagreement with each other when all of us said, well, the one thing we could agree on is that there has to be multiple batteries.
Yeah.
And this is exactly why. We just weren't able to like really fully recognize the extent of the reach of that same exact concept.
Yeah. It's funny how this works out. You see the two sides there, Joe, and I drew around like a figure 8. That's their donut. So let's just understand this. Without entropy, you don't have the donut. You have to start out with a sphere. The sphere pulls entropy in, then you have the donut. It's the catalyst for the energy exchange. Without that, you don't have it. So when you see plasma physics and they go around and they're trying to pull in the donut, just understand when you see it all wavy and curvy like that, that's actually resonance, okay? Because it's going back and forth between a positive and negative state as it turns, okay? This right here doesn't exist, the donut, without it. And people think donut, oh my God, the energy flow pattern, you know what I mean? The way that it goes like this. But they're not realizing you don't have the catalyst for it. You have the tube that goes around. You don't have the center. The part that cut out of the reactor is the main part you have to have.
Yeah, that's dead on, man, because you have to remember that this donut reaction only exists transaxial of the initial reaction itself. Meaning that the initial reaction happens central at the core, at the equator. And, if you cut out that central part, all you're doing is emulating the geometries. Same as a permanent magnet would attempt to emulate the upper dimensional geometries of a magnetic field. But as we know, they're static. And because they're static, there's limitations. They're the fields of a magnet really can't be saturated or manipulated beyond that of which they're constituted of in their initial formation. Whereas, electromagnetism works in entirely different ways. It works in layers and builds out in saturations, you see, and it has motion and flow to it. So by limiting the geometry to that of a donut, unfortunately, that's a fail, and it's only part of the understanding, because when you start to connect all the dots here with it, you just notice that the donut's still there, but it's just part of a larger spherical torus geometry as opposed to just the donut.
Yeah, I want to bring something up in this, Joe, and I don't think people realize this because sometimes they don't realize how energy works through the parts. So this right here is an AC flyback. So basically what it does is it sloshes back and forth, right? So your anode becomes your cathode, and your cathode becomes your anode as it sloshes back and forth. The higher energy state goes to one side versus the other. Now take this into an understanding. The sun itself flips the poles. So it's flipping between which one's the higher and lower energy state every so many years. Just understand the RAV's doing the same thing. Because of the way the AC flyback works, you're putting in a magnetic field in order to start this one over here, but then it goes back and forth in an AC slosh. Without the AC slosh, it's not an AC flyback. It's just, magnetism. So the fact that it goes back and forth like this, it's changing the relationship between the anode and which one's the cathode. Because in all honesty, they're both the same thing. Now, if you do the double RAV, you can see it more clearly, because then it'll go like this to you, right? You go boom, 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 boom. But now just understand that it's doing that here. So it's pole shifting the center, which you would say is the sun, right?
Right. Flipping polarity. Remember the song that I wrote? That's
your pump.
Watch what this motherfucker does when we flip polarity. Come on now.
Yeah.
Exactly.
But that's why it goes like this. The RAV itself goes like this and flashes, right? It's because it's a pump. It's the energy pump that goes on in the energy exchange. It pumps the energy around throughout the entire thing and just goes like, it's like a heartbeat.
All right. I'm gonna blow it wide open, and this is gonna be the skull cracker. Well, when your pole shifts, you must understand one thing. It doesn't flip like that. It flips like this. You see what I mean? It flips from the outside in out.
Okay, opposite of the way we normally think about it.
Right. So what you see, what the observation is this. Okay. Which then says rotation, right? But what actually happens is this. And the observable of that internally and externally is this.
Mm-hmm. It's same thing goes on with the Earth, whether you know it or not. We're not a perfect sphere. We go in like this all the time. And scientists, sometimes go, well, we don't know why. Well, I know why. It's because you have to, because it's a slosh relationship. It has to go back and forth. We're on a sheath zone that goes on from the sun right there. That's where we're getting our power. They say, oh, no, it's the power from the light of the sun. It gets there and it travels. That's a bunch of horse pooey. Let me just tell you why. If it was that way, then the International Space Station would be on fire every day, because it couldn't withstand the energy that's coming through it, because it's not coming from there. They call it spooky at a distance because you don't normally see the sheath lines going on it. But in the RAV, it's telling you a different story. Everything builds out a satellite on the sheath line, which means the Earth is a satellite of the sun itself. That's why it takes 100 Earths to fit inside of the sun. It's massive. I mean, this thing's energy exchange. You're pulling out the sheath zone, and we're over there pulling the energy out of it. The problem we have is a solar storm that comes in from the sun. It shoots out, and it'll hit us. And what it does is it pushes upon the outer layer of the planet. And that's when it starts to cause problems, because it takes the cold plasma that's going on there, it turns it into a hot plasma in a few seconds. And as soon as it does that, your body can't handle hot plasma. Okay? It can handle the cold. It cannot handle the hot plasma. And we start to have problems as human beings. And everything of the electronics that we build are affected by it. But let me just tell you, In ancient history, they didn't use energy like we did. They didn't use any part of it. You think, oh my God, I see a Baghdad battery, but I don't see wires. Where are the wires? Okay. Where's the understanding here? And I'll tell you where it is. Okay. And I'll just let me run for this for a second, Joe. If I took the wire out, I can replace it with a vine. Why? Just think about it this way. In the experiments that I did, I hook it into a grape. And I say, well, a grape shouldn't be able to transfer the energy from one to the other, but it's the water content in the grape. It transfers it over. Then I put things in big buckets of water. It's transferring through the water. It's acting differently because it's all ion energy. It's not a magnetodielectric energy. So why would it go through the vine? Because the vine has a water content. I no longer need a wire to connect it because the vine does it. Now let's look at the hieroglyphs in Egypt. When you see the light bulb, one side shows you what looks like a Tesla coil. The other side shows you a vine going into the light bulb. Why would that work? Because the vine only has to be in the water. If you pull ions from the ionosphere down to the pyramid, you know that you stand there on the top, you can fill Leyden jars, right? Which means the energy potential is already there. Take the pyramid itself and make it full of water, right? Through the wick effect from the bottom. What happens? The energy transfers through that into the water. Okay, it goes down into everything, and all you have to do is put the vine in water. Hook it to a light bulb and it'll turn on. It's the water content that it travels in. People do not understand this. They did not have the same power source we do. We run on a manipulated man-made system that creates a hot energy, a fire hose. That's not the way they did energy back then. Back then, the ionosphere brought the ions into the water and makes the water table vibrant. Now the water table goes into everything and grows the plants 4 times as fast because what are they trying to do at all times? Plants are reaching up to the ionosphere, reaching down to the ions themselves in the other layer that's underneath us we don't realize is there. As above is so below. That's because of the ions themselves. Now understand that they understood this technology that we fail to even grasp today. If I didn't do the water experiments, no one would ever know exactly how this thing works. But since I did, now we could take it to the next level. Do we need wires? No. What do we need?
Right.
We need
Just
water.
drawing in the relationship between the heavens and the earth.
Yes.
Is the energy exchange that you need to capture, and then you have all the energy you need. I mean, look, I've said it 1,000 times, right? The white dot, the white page tries to consume the black dots on the page to make more gray, right? Well, I mean, if you think about it as a white dot and a black dot instead, okay? Well, the white dot is your sun, and your black dot is your planets. And, sometimes the white dot kind of wins, and then you look at the desolate planets, right? They're desolate because their energy deplete of their material. For the most part, they're all but consumed by the white of the page, the sun. But when we're here, okay, and we're in some kind of asymmetric exchange that has all the components, right, where we have all this hydrogen locked in water form, that has also created more complex chemistries as far as elemental matter is concerned, where energy is just locked up all over the place in this planet, from the core to the surface and the atmosphere. You must know and understand that by virtue of looking at the magnetosphere, our magnetic interaction with the sun through that energy exchange, we think of this relationship between the earth and the sun as a one-way circumstance, where we get the energy of the sun, and then whatever energy didn't hit us continues to travel on and then hit the next thing that's in its way, another planet or celestial objects, until it's just diffuse. And that's just how it is, right? No. You see, what hits us is still giving material back as energy to the sun. Like, that's plain and simple. Now, whether that's observable, or accepted.
Well, let's look at it.
I
Hold
think
on.
it's neither here nor there.
It's right there.
Of course, it's right there. But I mean, this isn't our analogy. But yes, I know it's right there for us. But like on the larger scale of things, they don't tell you that the Earth also feeds the sun.
Well, hold on.
But it has to. It's part of the relationship.
Let's understand this. Take this plasma right here, right? Say that's the core of our planet. And this over here is the sun. Obviously, there's a size difference. It's not real in the way our sun's energy read. This would be a lot smaller inside of a planet than it is right here. But just understand it in this way. The sheath line comes out. You can see it clearly. It goes over there. It's feeding this plasma. And then it comes back over here to the rad. So what does it tell you about plasma and the nature of it? We all don't deny that the sun's plasma. We all know that. So when you create plasma in the lab, it gives you a very distinct point of view. You see it goes on the sheath line, builds out on the sheath layer. Now, what's missing from this right here to create ball lightning? Now, this is something that Bedini talked about, and I sent everybody a video a while back and put it up on the channel. Bedini said they had a guy that came in with Bearden, and they created ball lightning. How did they do it? They put a vacuum to the plasma in the energy exchange. Here's the plasma right here. No question. How do I get that? I need a vortex to pull upon it in order to close it as a teardrop. Right now, it's not the teardrop. It's not folding over itself. It requires the vacuum to do it. And there's not a high enough vacuum because the outer layers of the sheath are not built and rotationally different than this one's right here yet. Ball lightning is very simple, okay? It's plasma built on a sheath layer that has an extenuated vacuum that hits it and then pulls it apart from it. And then it's free to go anywhere because it's a trapped energy now. It is now closed. This is open on one side. It's not yet closed. That's all ball lightning is. Everybody thinks it's something bigger than that. It really isn't.
I mean, I agree with you, man. Like, there's just a missing dimension of geometry.
It's the vacuum part. You need another vortex to it.
Well, right. And how do you get that vortex through another layer of
counter-rotational? Yes.
Yeah, counter-rotational magnetism. Exactly. So, basically, well, then that comes into play with how you said two ravs. Right, because when you have the two ravs and an interaction, now you've multiplied your fields again, but not by 2, but by 4.
Okay.
But then they go up exponentially too, because there's then double the amount of interactions between each entire field as well. So it becomes that 4 becomes 16. And you have 16 field interactions occurring just by making 2. And that's sort of...
Okay, let me show something, Joe, as soon as it'll pop up here. Because I think it needs to be seen.
Right, because then you have right, and then if you have 3 like Ashton Forbes, then you have 32 field interactions. But then it's not 32, it's 64. 120. You have 128 field interaction from 3.
All right, let's look at this the right way. You see the little dots inside there? That's what comes out when you see the RAV and it shows itself, right? Those are the ions inside. Now, what's going on? They rotate in the same direction when we create the original RAV, like you just saw in the energy exchange right there. How do you get it to change? See, here's the thing about ions, and they say this in plasma physics. When there's too many ions in there, it compresses too hard, and then you get too much energy inside, so it wants to explode. That is the reason that you get the north and south pole of the sun flipping, okay? Because it's too much energy. Now, when you understand that, you understand the next part here. One of these little dots is going to go counter-rotational to take the stress off the entire thing in compression. When you do that, now it changes the sheath layer of that. So we're originally going here. Now you're going here in this direction because of the stress of it caused one of them to change directions, okay? And then you do it again and another one changes. Now, it's important to understand that because it's mechanical. This is very much a mechanical system the way it works. As soon as each one flips, you could start to understand this. Magnetism is built in layers just like this. Okay. You have your outer layer, okay, ferromagnetism. You have your inner layer, okay, your boundary layer. Um, and then you have your ionosphere, okay? What you're dealing with is a system of different layers of magnetism that go on. The
Yeah.
boundary layer slows it down, it's paramagnetism, right? And then we get into the inside, okay? And it's completely separate from both of them. When you do that, you could just do this. Take the amount in an atom and find out where the neutrons are. By the number of neutrons there are, that's how many things have changed direction in an atom. Therefore, it'll tell you which magnetic state it is. Okay? And when you know that everything in this world is now a simple precision machine that's built inside of this. Every atom is built that way. Every plasma is built that way. Every solar system is built that way. It's predictable. Why would nature have a code for every single different thing? Why not have one unpacking code that simply tells everything how to open up and work? Okay, you take a zip file, you unpack it, it tells it which way to go, which directions to make it go, everything, just to make that single item. But then it's in equilibrium because a 3-leaf clover sometimes becomes a 4-leaf clover, but doesn't destroy the 4-leaf clover because it's not an equals, it's an equilibrium. Okay, and then you understand it, guys.
It's the paradoxical
Yes,
non equilibrium
equilibrium.
state. Yeah, because it's in a perpetual state of non-equilibrium that balances itself out into what you would perceive as an equilibrium, and in through an asymmetric exchange of differentials. Like I said, it's exactly
Exactly like you
it's
said.
how it all works. And why don't you see this stuff occurring normally or whatever? Like we've been playing with electricity for hundreds of years. How come turning on a light switch doesn't induce this sort of thing? Well, I mean,
I
funny
think
thing
Joe
is,
froze.
so slightly it kind of does at a very small scale that you would never recognize. But the truth is that because you're only running one circuit, and the circuit starts and the circuit ends, right? And then that's its path. It doesn't cross anything else. They forbid you from running another circuit into it and cross it because you start to get things, and when those things happen in your walls, they start fires. When those things happen on your circuit board, they start fires. But when these things happen under the right conditions and they're separate by an insulator that's going to be defeated eventually, the things you want happen. You see, they've literally engineered this stuff out of the equation.
Wait, here's the thing Steinmetz knew, and I don't think anybody really kind of realized. It's not really a closed system.
No.
Your AC is not really a closed system, and I'll tell you why. Okay, on a hot summer day, the wires in your walls will heat up, and as soon as they heat up, your air conditioner shuts off, right? But then you go, well, only if a high amount of amperage you go over and turn the breaker, right? So what did they just tell you? The heat itself, compressed in the energy of the wire, adds to it by the surrounding environment, therefore shutting off your air conditioner in the heat, right? Is it really a closed system at that point? Because it's not.
Not at all. Not at all. Not in the least. And it's not like the misnomer of it is that the closed system is a closed system. The closed system occurs through the interaction, like I said earlier, right? The interaction of other open systems. So there's other open systems that are in onto themselves, but then what they have cumulatively, becomes the closed system. What that exchange is in between those two becomes the loop of the closed system. So it's not the way that you think it is. It's why you needed more than one battery on the gravifier, or why you needed more battery to achieve over unity. You couldn't do it with one I argued you couldn't do it with 2. I argued you needed 3. That was my take on it, but it doesn't. The point being separate doesn't matter. The point is that all 3 are intrinsically tied together through what forms to be a closed loop system at that point.
I know. I want to shout out real quick, Bernie. Hey, check it out.
Right on, dude. What's up, Bernie?
Sorry, I can't even do this. Bernie hooked me up with a shirt, brother, last time he was out here, man. He gave me just a couple of them, so I'm wearing one today.
I love it, dude. That's cool.
Yeah. Bernie did his presentation, by the way, at Tesla Tech. He showed it on his channel a couple of days ago. Absolutely outstanding. I had a chance to witness it in person. Let me tell you some of the stuff that goes on there, the layering effects that goes on, the colors. Absolutely beautiful to look at, man. It tells you a true story about exactly how atomic mass works and how everything divides out. It's why people don't understand. You take away the wind effects and everything just builds out in atomic mass. So all you have to do to create anti-gravity is change the atomic mass in the object that you're in by adding a bunch of ions to it, and it changes it. And I find it hilarious to know that, because Hutchinson was doing it right in front of our face, and he just created an ion field that went like this, and it filled everything full of ions, and it lifted, changed the atomic mass of the object. And here people are still trying to figure out what the hell he did, and I'm laughing at it because it's pretty much easy once you understand how the ion works, because that's the only energy itself that can be compressed inside the magnetodielectric in order to create this state where everything in there weighs less. Now, you wonder why you take the bumpy aluminum. That's because when you deal with ions, they like to collectively pool inside those little channels, right? You take the shell of a beetle. It likes to pool inside those little channels. So what happens is it creates a atomic mass that's less than the object itself and lowers it so that they can rise faster. So it's not that hard once you understand the players in the field.
Yeah, that's dead on. I mean, what Hutchinson was doing was also destructive to the material, and we know that too because of the method. Because like obviously, but the stuff that floated. I think that people have it separated in their minds sometimes. Oh, look, it just took off, and then he shows other phenomena where the stuff twists apart, crumbles, falls apart. Dematerializes to a certain degree, and those things are separate in their head. Well, actually, the way that he was achieving it, in my opinion at least, was actually through the same exact means, just at different levels. If you crank it high, it occurs fast, so the dematerialization occurs before the reduction in the mass, because that's just it's literally dematerializing, and then what remains is the undematerialized, which remains at the same mass. Now, when you do it in the slower saturative manner, okay, it's actually doing it in a modulated form. Okay, that's actually doing the same more or less thing to the internal structure of the material itself. Okay, but it's also still able to reconsolidate back to a certain degree, more or less. And I would guarantee you that if you picked up something that lifted up from him and flew and did the nuts thing, like it was like starts to rise and then goes blah. Anyway, if you were to cut one of those, and put it under a microscope, you would see, if it was a before and after, you would see clear pore structure, from what did not fall into its lattice structure. That's what I think. But what Nathan's saying, it's dead on.
So check this out. The reason I know that the inside of an atom is ions, it's something very simple. As soon as we have anything that's metal, right, we look at the ion content in the metal. Why? Why is it there? You see, they say they hit 2 electrons together to make an ion, but that's not exactly true. Okay, they hit them to loosen an ion from the magnetodielectric field that surrounds the ions inside. In that understanding, now look at the piece of material. If everything is atoms on the inside, why is there an ion content in it? Because the atoms themselves are made of ions on the inside. And as soon as you put electromagnetic energy around it, they want to bond with it. So they try to pull out to it. So understand this. If I take the magnetodielectric and change it from a linear form in a wire like this to a 360-degree compression field now, what happens? I take the ions inside of everything that's in there, and I now force them in compression. The amount of energy is like 25 to the 25th power. It's an absolutely amazing amount of energy that goes inside of this. If you do it instantly, like Joe says, it tears things from the inside out. It literally takes the ions inside there and tears them up. Now, how do you visually see it?
Remove them entirely.
No, well, it doesn't
Pulls them out.
remove them, it compresses them, and the metal itself tears apart. So the part that became mass tears apart. Now, how do you see this? Let me just tell you a little secret. Take some bismuth. Go over and get your heater, okay? Your ZVS, your heater, okay? Create a little vortex out of the thing, okay? So that has a bottom. Now take your bismuth and drop it into it. It'll immediately melt down, but it's going to show you something very important. You're going to start to see those circles form on the inside, okay? And they'll be clear. You'll see metal all around and these little circles that show up on the inside. It's revealing what it is. On the inside, the ions and shells are showing themselves of the metal. Now you know, okay? So,
right.
So hold on, I just want to make this one point. So when I tell you an atom is equal to the same thing as plasma, is equal to the same thing as the planets, understand it doesn't come out of nowhere. It comes out of the exact experiments we're looking at. Go ahead, Joe.
So the side of ionization, it's just the same thing over and over again. The side of the ionization is the manipulation of the electrons that are the binding material of the rest of the material structure. So when you're when you're inducing fields that are pulling through an exchange those valence electrons out, then creating, what should be a stability, but it's not. What did I say? When you create a void, now everything's got to fall into its place, right? Now all of a sudden you're fundamentally changing the entire lattice and material molecular structure of the material itself by yanking electrons, which then cascades into the ionization procedures, creating the gaps, and all this. Now, here's the weird part, okay? And it's probably one of those other quiet parts out loud, right? Is with this stuff, right? How important is this loop that's created of all these other, fields? Critical, because guess what? Where you have plasma, you have material consumption, energetic material consumption. Okay, that basically would mean that when you're in space and you're traveling and you're using plasma as a means of propulsion, that means that you need, you're always going to be sacrificing part of your craft, meaning that you are then limited to the same bullshit physics you were limited to in the first place, which is fuel, because at that point, the material itself becomes the fuel. So that's where you have to backtrack and say space travel is never plausible. And the only way that space travel is plausible at the light year height level, right, is going to be what we've talked about all along, which is total disassociation, phasing, and that's it. And that is actually part of this too, because what ends up happening when you have total dematerialization is you have a phase change. But, as organic beings, it's a little scary to have to think about. But, it's sort of...
Let me say this. Otis T. Carr said this best, okay? When he talked about his UFO device, he said this: when you get up in the atmosphere, it's now over unity. Why? Because he's pulling in the energy from the environment around him. So what happens when you get 100 volts per meter, right? When you get up in there, that's a ton of voltage. He's not using magnetism in the way you think, okay? Everybody thinks of this things like the fire hose coming out of your wall. They think of the DC power that you use. Guys, the amps are unimportant when you get to this level. It is the voltage that matters. Just understand that. It's like I said with the Egyptian stuff. You're thinking about energy the wrong way. You continue to think magnetism. You think, I need enough heat. I need enough heat. No, you need a small amount of heat, and you need a ton of energy, right? It needs to be that way. Coupled fields in the environment require a higher state of energy and a very small amount of heat, okay? That's what drives people nuts, because they go, No, it can't be that way. It can't be that way because every time it comes out of the wire, it has a ton of heat. What's your amps? What's your amps? Your amps are worthless in this context. It is the smallest amount that just has to be there that comes into it. Okay.
So, okay, all right, hold on. So there's a weird situation going on here because it's a conundrum and it goes around in a circle. See, because it's both. And, the thing is like you actually, as you're reaching peak efficiencies, right, you would think that means elimination of heat. And science knows this, and you know this too, right? Like if you want to reduce the resistance of something, cool it down. If you cool something enough, it slows everything down. By slowing everything down, all the physics changes and the efficiency levels go way up to the point where we know that superconductivity is possible at the lowest possible, temperatures. But that's not the problem. The heat isn't the problem. It's keeping the heat separate of the low energy state. So you could make as much heat as you want. In fact, the more heat you make, the better off it is because
I disagree completely.
hold tight. Because of the exchange, if the heat is as a result of the byproduct of separating your low energy state, meaning that you are effectively maximizing Maxwell's demon to the fullest extent, to the point where you're bringing all the high energy state out, consolidating it over here, and then taking your low energy state and consolidating it over here. And then the only interaction that you allow between the two are that controlled exchange, which is exactly what we've been doing and exactly what I've been saying. But that's where that high temperature comes in. You see, it's not that you want the high temperature, okay, for the benefit of the system. It's that the high temperature is the signature of the system working.
Okay, I need to explain this. In sheath zones, the temperature is very low. You got to understand, this is what I'm talking about. The energy in the planet, they're not in high amps. It's only the compression in the core that creates the amount of energy that's the heat that Joe's talking about. When you get outside of that, that's the field that we're in. There's not a whole lot of amps going on everywhere. You got to realize this when you're talking about energy and how they use it. If we're creating UFO craft, the last thing I want in it is amps. I mean, it'll drive me nuts, okay? Because that's not the field that I'm in. If I'm close to the core of the earth, then I can understand the heat and why I would need it, okay? Because the energy is much different there. The heat is actually higher. The magnetic field is higher. All of it's higher, right? So I needed to break through, but I'm not in that field. I'm in the field of higher voltage, okay? I'm in the field of ions. When I start dealing in that, I need a higher electrical potential, okay?
Mm-hmm.
That's what it's telling me, okay? Because that's the energy field that I'm in. Just understand that there's a difference in where you're at. So this is why you can't throw a magnet out in the middle of nowhere and have it spin up and work, right? And just sit there and float because you're not in that field. You think that you're in that field. Most people understand energy in that way, but it's not true for where you're at. You're in a sheath zone and you're up over in the ionosphere area. Therefore, you're in a high electrical potential everywhere. And that's why it rises 100 volts per meter, guys, because that's the zone you're in. You have to realize that. Now, a lot of people don't. They think, oh my God, I got to have it. Magnets everywhere. Magnets control everything. Not in the zone we're in, buddy. Okay? Not in the zone of space. When you get to space, it's even worse. You see, it's the whole air concept. When you start building things from different levels, okay? You get in the water, okay? How do you get out of the water? Okay, you put air in it, okay? How do you get out of the air itself? Then you put a high potential of ionization in there, the energy. Now you're in space. It converts again. It's a predictable pattern because it always builds out in one way. We got crypto coming in. What's up, Bernie?
Very good.
Hello.
Bernie.
So, in regards to what you guys are just explaining, and you're bang on, and it's the high voltage is cold plasma, and that's our density, and then the inner high amp is hot plasma, hot density, and that it's a boundary layer, right? That, for instance, like how the star in the jar reactor works, is that it's the outer ionic barrier, the ionized plasma barrier of an atom. That is the hot that they need. You would have to have it interacting at that energy to break it, to breach it, but you don't have to have everything in that field, like in that density and pressure going into it. You just have to have it contained, right? So it's the difference between why a tokamak hot reactor doesn't work compared to the natural star in the jar, the temperature of the plasma arc being contained within that liquid water working.
Yeah, right. It's totally the point. And there's this idea here where the differentials are all of them. You know, it's high pressure, low pressure, you know, high density, low density, light and dark, high, you know, high voltage
And
and
so
high
that
amps
each
on the
one of
other
those
side.
plasma barriers they're within the four circles of standing waves that make up the atom, right? That they're different barriers, just like in the RAV, we're seeing the formations, the build out of it, and that each one of those forces, each one of those pressures, those densities, they're all contained within each other, but they're separate from one another. You can't just smash them all together and expect it to work. You have to be able to just get it in that lattice correctly.
Right. So imagine this. Imagine you had two boxes, right, of flies. All right. And one box has flies in it, as many as you could fit, but they're all flying around. Okay. They're flying around, they're banging into the walls, they're banging into each other. If you were to, you know, but because they're all flying around at this high frequency, because this is what it's going to boil back down to is frequency. Okay. Because they're all flying around at this high frequency, there's only so many that you can fit in that box. Whereas the same exact size box and the same exact size flies, you could fit a lot more of those flies if they were frozen and dead.
Absolutely.
Right.
And it's exactly that frequency, right? So the frequencies you have to have they're fields, right? They're field boundaries, and that you have to have the right frequency going in that it'll be able to penetrate those outer boundaries because it's on that right frequency. You're not cramming it through, it's just able to go in and interact. And thus, from that, you're able to get through one field or a different field, breaching it without destabilizing it and without crushing or breaking it.
Right. So hold on. Let's take that same example, and this is exactly what Bernie's saying, right? With the flies. Well, if you take the two boxes, but then you end up putting them in one box, right? Entropy says that your flies that are still alive and flying, okay, should be able to just fly directly through the bulk of dead frozen flies and homogenize with them and still somehow, you know, be moving through. And they'll never stop flying through that dense pile of frozen flies. But we well know that if you were to do that, they're not going to be able to fly through the dense thing of frozen flies, right? They're just going to end up flying around it. And that's exactly the stability that you end up with.
Is that Schrodinger, how you use the aspect of flies instead of cats, everyone would understand Schrodinger's flies and not his cat box.
Well, pretty much. I mean, but, you know, cats would be a little bit more difficult for the analogy, I think. But, you know,
particle wave duality is what it actually is, but that's a whole other episode I won't get sidetracked onto.
Well, now the funny thing is with Schrodinger, now if you open up the box, chances are all you're going to see is the flies, right?
Yeah,
that are alive, because they're all flying around. You know, this dead mass in the center that you'll never see through the flies that are alive. You see the thing, but they're both there.
All right, let's start talking about flies for a second. I'll show you something. This is Sean over here having fun with us. Okay?
Oh, that's a micro Rav, but then he's got the opposite of that too. Today's opposite day.
It's cool if you see this thing in high definition. Okay, when you watch it on the shorts on the channel, I want you to see something. The yellow itself forms a perfect ring. Then there's a black ring that goes on the inside.
Mm-hmm.
And then inside of that is the white, but you see the white and it comes up and it's like a teardrop back to the anode itself.
Oh, yeah. Mm-hmm.
So when you see this thing in high definition, man, you see it on the Shorts channel, it's absolutely amazing because he's capturing like a single ion in the center and it's building the magnetodielectric in yellow. And then you see the boundary layer in black, which is the most condensed energy in there, and it acts like aluminum does. So when we get to things like the gravity flyer and stuff, why do they use aluminum all the time? Because it's paramagnetic, and that's the exact field that is the boundary layer. It's paramagnetic. So what does that mean? That it doesn't want to sit on the aluminum itself. It likes to go on the outside and push energy from it and go on a field around the aluminum itself.
Mm-hmm.
So what does that mean for a boundary layer? It means that as you go through the ions to convert over to the magnetodielectric where they couple, it means that it slows down. It's slowing down that energy in order to get through it. It's very dense, right? And then it finally forms and combines together to make the magnetodielectric on the outside, which is just two ions put together that move back and forth and give you your frequency as they move back and forth, but they're coupled in a field together as they go and swirl around a vortex.
So you just said something crazy, and it's something we never touched on, but it's so apparent that this is how it goes. But how it builds in those layers in the first place after it forms, okay, is because once it forms, the plasma that's in there, okay, is actually structured and set, okay? And what that acts as a carrier reservoir for the new plasma of the same to take a ride with it. So what that ends up meaning is that you have the exchange occurring through the RAV, through these sheath layers like Nathan's describing, but you also have it's a seed of a transient crystal formation, okay? Mm-hmm. And what I mean by that is like the initial plasma that's in there pretty much remains in its stable structure, and everything else is literally swooshing around it transiently, and passing through. And then every so often, some of those particular, charged particles may exchange out with a transient one, but that doesn't matter because it stays in the initial configuration. And that's how it works, is off of the seed crystal, literal seed crystal of plasma.
Well, hold on. So let's go further into this. Anytime we do transmutation or that we want to create an element, it's based on the amount of ions inside the magnetodielectric. Let's just understand that for what it is. So why do you need to ionize stuff in order to change the energy itself in the thunderstorm generator? Because you need to loosen the field itself of the magnetodielectric enough to add ions or remove ions based on the other material that's in there. So as soon as you know that you know the ionization on the inside, just like it is in chemistry, as soon as you change it, you change the material, right? It's a difference in the acid-base relationships and how they work in the all the chemistry stuff. So now that you know that, okay, all you need to know is how many ions do I add to this? So if I look at say the pyramid over in Mexico, I know something very specific's going on in there, okay? I know the ions are coming from the ionosphere. I know that I have liquid mercury in there, and I know I have crystal that's going on in there as well at the base of the pyramid. What do I have? I basically have a piezoelectric disc that's putting out an ultrasound that's going on to the mercury on the inside, which is pulling ions from the ionosphere, and now it's changing the mercury itself in the chemical formula. It's not the city of gold. It's the city that makes gold, okay? It's understanding ions at their level and how they work in chemistry in plasma, because they're not so different. They're all in the same exchange.
Have you ever noticed how the sun flips its polarity approximately every 11 years?
11 years, but it hasn't done it since 2001.
At this point, but I mean, historically, it
was every 11 years, and it would reset the.
It's better that it hasn't. It's better that it hasn't, and I'm going there because the idea is that it works off of.
Or a white pulsar sun, and it's changed its whole process, so that's part of it. Sorry, go back to your point.
Yeah. So you have your polarity flip every 11 years, but then it sometimes goes on these tangents.
Well, it
right?
never. Sometimes it just never did. Now it's a new cycle, and now it doesn't do it anymore because it's a new cycle.
Okay, well, regardless, it has to do with frequency and energy exchange is the idea here. Okay, and what you end up
100%. And now it's at a new frequency of a white pulse sun, so it's acting completely different with the frequencies being put out, and why we're getting exponentially more discharge from it, and why we no longer have sunspots only being limited to the 33rd parallel. You see these open gashes going all the way from pole to pole, and we're getting crazy coronal mass discharges where we're getting auroras all the way down to the equator on Earth now, because it's a different cycle at an exponentially increased frequency, and the
right,
energy.
and our pole is shifting and shifting and shifting faster and faster and faster because of it.
Exactly. And
So
our magnetic field of the Earth has changed completely too. Where we're like, oh my God, it's collapsed. We're going to die. Except now it collapses when there's no solar radiation coming. And then as soon as there's a flare, it flares up to the equal amount as what's coming out us and deflects it. So it's a perfect symmetry, and we survive and we don't die.
so
That's what's up.
the idea here is that it's these pole shifts that are the pulse. So if it stops pulsing, okay, that's the change in frequency. It's going to pulse again at some point, but
Joe, now if you look at the sun, it's actually continuously pulsing, and that's what part of becoming a white pulsar is that it's
well, it's a beat, right? What the pulse switch is though is when the beat frequency between all the interactions coincides with a flip for the equilibrium. The point that I'm making is this: when you're looking at RAV, okay, we know that the anode is the positive side, right, and the cathode is the negative side, so we call it, okay. But the polarity of the RAV, okay, is not measured, okay. But I would certainly put out there that the RAV itself is in a constant state of polarity shifting, okay, at a much higher rate.
exactly.
And when you bring in the idea that there's a much higher rate of polarity shifting, that is a direct correlation with the energy exchange rate, and therefore, as I've proposed 1,000 times and in my paper, time dilation, which is directly then related to space, which is then directly related to gravitation. So you have the trifecta right there occurring on these polarity shifts through its cavitational pulsing. Okay, when it cavitationally pulses, you don't see it because it happens instantaneously, but there's a point where these things cross. And where do they cross? They don't cross in the center. That's why it's squat. Why? Asymmetric exchange. So they cross at a certain ratio, top or bottom, each time. But when they cross, they blink out of existence, you see? For a quick moment. And you see that as the flash of light when it comes back during the decompression.
I want to explain this about the sun so we understand this. We're in the age of Aquarius, okay? Basically the age of liquid, okay? Everything around is going to get hotter, okay, in a bit. And this goes around with the way Bernie explains the sun and how it's turning white. Now, there's a reason for this. We go through our universe, okay? And we have consistent cycles of where we're going in the vortex of the universe, right? So as we travel along the path, we're picking up the energy of the universe itself. Just understand this. That means the pressure on the outside of it is intensifying. Therefore, the energy is pushing the pressure into the sun itself, which causes it to go higher to an energy state. It's no longer in resonance the way it was. So what it's going to do is just like the RAV does when I build them, they go blast out energy everywhere, which is what the sun is doing right now. As soon as it gets through this area that it's going through, it'll reduce the state back to the original state, and you'll get the energy where it flips all the time again. That's why it's understanding if you understand the universe and the vortex that we're in and why we're going through things and they're not just coming to us, we're going through a field of garbage right now, a place where a planet or something exploded and we're going through it. And once you understand that, it all starts to make sense. We're in a higher, as they say it, a wasteful state, but a higher state of energy, as they say it. And basically, like every single thing, it just brings out the energy. So we're in a photon state where you see the energy go out and it's blasting out, and it's not allowing the switch to happen. And that's why it's called the Age of Aquarius.
Exactly. And so where the energy is coming from now and where we're entering into, right? It's the galactic plane that we're crossing back into. And as we're entering this galactic plane, the plane is all the galactic radiation, the actual galactic rays coming from the center of the galaxy, the black hole at the center, and it's the extra energy, the galactic rays that we are now being bombarded with. And as we go deeper and deeper into this galactic plane, we're getting into a deeper and deeper concentrate of these galactic rays, thus increase more and more and more energy into our solar system and into our sun, and why it's this golden age now of 12,000 years of increasing for half and then decreasing for half as we go into just starting right now, and then we'll be fully immersed into it halfway through and then decline back out, and then we begin the fall again as we get out of it. 12,000 years from now. Long time.
So Sean has videos at this point, and I've also shown my BBM mapping, which shows very, very similar stuff. But Sean has videos now where he's used his tools to be able to literally track the ionic path and flow patterns around his RAV experiments. And what you end up seeing quickly is that they directly represent and correlate with the solar patterns, depending on the stability or lack thereof. And sometimes it'll be chucking up goods all over the place, in very specific arcing patterns. Okay, like this in bows. Why? Because of gravity. That's why. That's why it's not being thrown off like radiation, where that doesn't have gravity. It's just unstable, right? This has gravity. This is throwing off radiation, and then it's pulling it back, right? But then other circumstances, you'll see it get thrown off and back in, thrown off and back in, and that's when it's stable. See, it's not putting off all that radiation at that point. But that's what you end up seeing is this map of all the flow. And it's not the photonic flow in that case, it's the charged particles, which is directly coincides with the photonic flow. So that's why there's such similarity in the, results. But at the same time, there's one that's a flow pattern and then one that's like a discharge pattern. The flow pattern is more electromagnetic, whereas the other, what Sean's doing is particles subject to that electromagnetic field. So they coincide with each other. They look similar because they coincide, but they're not the same. So he's doing excellent work too. And he built the RAV. He says it's the biggest one he ever built. He's there. I'm not. I'm looking at the videos. He says it's a 1/2 inch. It looks bigger than that to me. But a 1/2 inch RAV is no friggin' joke. I made a RAV that I thought was pretty big, and it was like maybe 1/4 of an inch, which is like, fraction of the size of a 1/2 inch, surface wise. And, I thought that was pretty friggin' big, and that was just on my, because most of the RAVs I was making, even when they looked good, they were teeny tiny, not to be foiled with for certain, but they were teeny tiny.
No, but the room was huge. It drives you nuts. What do you got going on there, Bernie?
All right, so I've got a bunch of vacuum seal packs, and you can see 1, 2, 3, 4. and that I'm going to be sealing. I learned from Kesh many years ago where it's like you put different monoatomics or the GANs sealed within each other, but when you use different elements and different states, for instance, there's the white single atom state, the neutral, then you have the blue oxidized state, you have the red hydride state, and you have the black ene state, like the graphene state. And that by layering each one between them, you're able to create a differential flow of charged particles between them. And that it was, Keshe used it for healing. And well, I'm going to be doing this, well, experimenting with, but more than that, that there should be actual energy flow and ion flow exchange between it from doing the right layering of these room temperature superconductors between the hydride on outside and the oxide. Sorry, wow. The oxide closer to the outside, and then the black ene state. And the black ene state, the carbon state, it's the one where you have the full particle to particle exchange. There's no loss, and thus there's no scattering, there's no radiation, there's no decay. It stays as a particle. You have a full photon, a full phonon, a full electron going through the outside lattice layer, and thus it's not breaking down into waves. You're not getting that radiation, that heat, that X-ray, whatever bandwidth your particle is in. It remains as a full particle, and thus, yeah, you get the full transfer of a reaction in it. And that is what I've been working on next here for some demos to try out.
Very cool, dude.
And of course, the purple. We love the purple.
Oh yeah, nice.
So it starts out as white, right? I turn them all into white, and then that one's. Ooh, we got Joe. There we go. We got the purple gold, but we also have the purple silver. So there's the gold, which is that color in purple, and then the silver that's that color, and then purple gold I was able to make during the summer solstice while making it, and then the purple silver I was able to make during the full moon during an equinox. And that's, I believe and suspect that it's a photon bonding with the monoatomic gold and silver, making it that purple. So it's physical particle of gold and light and a physical particle of gold and silver. And that's the specific sample that I took through the mass spectrometer at the U.S. Customs last year that did not show up or register as anything, and thus a completely new particle element. And I believe so from the photon being included within it. Some super nerd stuff.
So I want to make a comment on that real quick because
Absolutely.
It's something that kind of comes to mind and ties this incredible chemistry in with something that we kind of know is going on, right? So we know that they do cloud seeding, okay, and they seed these clouds with silver iodide, if I'm not mistaken. And what does that do? Well, I mean, it's conductive because they explain it differently, all right? But the fact is that that silver iodide is wildly conductive, and clouds are plasma, okay? And when you feed the clouds, as they put it, you're adding a very conductive element into what's already a plasmatic condensation that automatically draws in all the particles that are charged into it, creating a cell. Now, I'm going to throw it out there. That monoatomic silver would be far more effective in terms of it would probably create like a superstorm if you were to see the cloud with monoatomic silver.
Oh, absolutely. Compared to the oxide that they use.
Okay,
Yeah.
hold on. I gotta ask this because it comes right up. Anunnaki, 1 in gold, to seed their environment. Is it the same thing you guys are talking about?
So I was going to go there next, and
Okay.
and that's what I was suggesting too, was when you have deterioration, okay, of your atmosphere, and you know that gold is of its absolute purity, and then if you were to bring it into its monoatomic form, okay, it should really draw just about all elements, that are pure elements, okay, to it in order to recondense an atmosphere. And that would act as, like, in my opinion, and Bernie can correct me if his opinion is different, or whatever, but I think that seeding the cloud with monoatomic gold, okay, would basically push out all the heavier materials, all the pollutants, all the hydrocarbons, all the bullshit in your atmosphere, and basically turn it into a cesspool where you have a sludge layer at the bottom. Basically, it would precipitate out of the atmosphere.
Yeah, you get poison rain, right?
Well, you would get poison rain, but followed by a perfectly cleansed atmosphere, possibly.
100%.
Mm.
I like
that's
that.
better understanding than I ever got from the Anunnaki and gold.
Well, it's just a matter of precipitating out things. Like, I mean, Bernie, if you were to take that monoatomic gold and put it into a charged jar of polluted water, what would occur?
Oh, it particulates out all the other what the poisons or pollutants, right? And then it structures the water due to that lattice, that crystal seed you put in of that lattice, so that it only aligns with those, and everything else is forced to particulate and come out of it.
And in other words, it would be, not only would it precipitate out all the contaminants, but it would also infuse itself as, like, almost a safeguard to unpure material.
Exactly.
Oh, is that why there's so much gold in our ocean?
Yeah, that would make sense.
I mean, right there, boom. You know what I mean? It's cleansing itself, and that's the actual chemical process that's going on.
Right. And if you ever look at the bottom where all the sludge goes, all of the contaminants in the water, more like, they always work themselves out over time. It's self-flushing. It just precipitates all the shit out of the water down to the bottom.
Self-flushing until we over-contaminate it. And
right, it's the ratio, right? Exactly.
Yep.
There is such a thing as overdoing it. High pollutant saturations, but not enough stuff to pull it out.
And that's why, so a lot of people that claim they make monoatomic gold from sea salt and seawater through caustic, it's actually monoatomic everything that's within the water. But back in the day, before everything was polluted by man, you would have gotten a lot more strictly monoatomic ormus or gold out of it, where now you're getting everything of all contaminants, all pollutants, and thus, it's like you're just getting a fraction of gold, and then you're getting lead and aluminum and everything else, as well as the oxides. So it's not recommended to do it that way. We'll just put it that way.
It's just super cool stuff, and it just goes to show how bringing the right thing into an environment will actually restore the imbalances. And that's the entire point, because you could throw anything out of its ratio and then it's done for, right? And we know what happens. It's system failure. System failure occurs. Other secondary, tertiary, tertiary, whatever, the tertiary, goes on and on and on. All the functions then try to force, stability back by, trying to make up, because, right, I keep on saying it's a pulley system. There's a belt. You pull the belt, all the wheels turn, right? Well, I mean, if you take one of the pulleys off, well, the belt is loose, the other pulleys try to keep on pulling it, but doesn't necessarily, maybe they can, maybe they can't, but the thing is that regardless, it's out of tune and it's got to be forced. That's what happens when you screw with the ratios. And as we know, with anything that's trying to force itself into a state of stability, it often flounders and fails and falls apart.
Absolutely. Makes the threshold trying to reach that stability, but you turn the whole system off of its equilibrium, and you can have catastrophic collapse, absolute collapse of a system, right? If it's oversaturated.
Right. And then weird stuff happens, like planets get pushed out and moons get pulled in, and distances change, and axes change their angular relationships, and poles shift, and the whole entire magnetism is obviously subject to all of these things. So then your magnetism gets screwy, starts pulling in, pulling out, flipping, trying to do anything just to keep it stable. And it's like a top when it stops losing its spin. It starts to wobble about, trying to keep that central axis point. Starts wobbling about just to try to keep it, but can't, because it's losing its steam. That's the scary shit. It happens. It happens.
And that's what's scary when they mess around with stuff like that. And for instance, CERN being a prime example where they're putting so much energy in that it unstabilizes the barrier of an entire planet potentially, or a planet or entire solar system universe of the base lattice structure of the barrier of reality.
I mean, right, and I agree with that on all fronts, but like in a more physical, way, when you're creating that level of energy density and magnetism, in a ring like that, and it's underground, you're either immediately going to be pulling in potential energy from the ground or pushing it away. Okay, which is automatically going to change the ratio of the energy exchange in that area from the atmospheric energy and the earth energy innately. And that's an unusual thing. And depending on what your polarity looks like and where the axes are and so on and so forth, would be deterministic of where your highest energy density levels in exchange is going to occur. I mean, if they really cranked that thing up and ran it, I mean, there's no telling what it's doing, because all the magma, as I said before, they say, oh, it's like liquid rock. I mean, that's a great explanation for like when you're telling a fifth grader what it is, and like there's liquid rock underneath us. Do you believe that shit? It comes out of the top of volcanoes, the same stuff. Listen, it is material in a state of in a state of potential and high plasticity, and it is yet to be determined what the fuck it is. And it doesn't the material and elemental composition of it is undetermined. No matter what they say, it's undetermined. It only starts to determine as it starts to slow down.
I love that. So accurate, and that's where it should be. Schrodinger's magma cat. Is it a plasma cat? Is it a crystalline cat? Is it a black hole of a cat? That's the real Schrodinger cat right there.
Yep. Yeah. High density in a low potential. Even though it's a high potential, it's still a low potential compared to the atmosphere. The high density, low potential, just matter in a condensed and undetermined state. And this is why you have all sorts of different types of elements in your bedrock. This is why the bedrock is not the same everywhere all the time, because its solidification, and what it became was deterministic of the resonant and cymatic functions at its time of solidification from its potential state.
Absolutely.
And it goes down to the point where this is how you could have things like granite, where it's both a feldspar type material and a quartz type material, but it's granular, right? And it's interconnected, is because that's literally the cymatic pattern okay, that was occurring, and then it's flowing into each other and then solidifying in that way. Then you have other types of bedrock that kick around all over the place. What's deterministic if your bedrock is going to be basalt, or it's going to be granite. What's deterministic there?
Right.
You-
How does the silicone form? How does it crystallize? Is due to those factors exactly.
exactly. And then you have the secondary ionization in water that occurs at deep levels, high pressures, okay, where water has no business being water, but because of the pressure it is still, and it becomes ionized again cymatically, and then based on that resonance of the material potential that's put into the water at that point, becomes your material composition that we consider to be a brine solution for further crystallization through hydrothermal processes. So what you would consider to be like a quartz crystal, for instance, right? If you look at secondary formation quartz crystals that are made from hydrothermal, I don't believe that they consider those to be igneous events, but they are.
Yeah, right. Exactly. And well, sometimes metamorphic, they might say, but yeah, it's more than igneous, more than metamorphic.
Right. It's more of an igneous reaction, and I think that even an igneous reaction is a bastardization because I don't think
Agreed.
that granitization, igneous formation, is the same as surface surface igneous rocks, such as uh, like all that lava stone and all that sort of shit.
Magma stuff like
Magma, when the magma comes up and it
plume
solidifies,
or
it's a
pumice.
whole different entire thing. And you know what's funny is that shit always comes out the same. Ever notice when it blows out the top of a volcano, it's always the same thing and always the same constituents?
Yeah, it turns into the pumice, right? The light,
Right.
fluffy stuff because it's at a different barrier condition pressure when it's solidifying.
Right. So the pumice comes out the same, more or less, right?
More or less, exactly.
More or less the same, whether it's blown out of the earth in Hawaii or Pompeii or
The
where
Himalayas or under the ocean.
right,
Well, different
anywhere
under
on
the
the
ocean
earth,
than on Earth.
Iceland,
Exactly.
wherever it comes up, it all solidifies into the same thing. Yet when it solidifies under the surface, it solidifies into all sorts of different things that are not the same thing. So how is it the same? How is it determined? You see, these
I
these
agree, Joe.
these,
And
these
it's
fuckers
like,
don't follow their own logic. Is the problem?
well, they're trained like that, and they're what's it called? Like yeah, just led to believe that, and cognitive dissonance created so that they can't figure it out, and that it's absolutely more of an electrochemistry, electrolysis phase shift reaction in a lot of the formation of geology and crystals than what's currently accounted for.
There you go.
So here I'm just showing a couple recent samples of new aerogels that I've made and collected here. And as you can see, it is both crystal and a gel simultaneously. And these are the see-through, clear, translucent, pure metal elements as crystal gels. And I'm able to make every metal atom or elements also into these. And the top one is aluminum and zinc, and then this bottom one is silver. Samples just made.
When
And
they crystallize, are they crystallizing in different geometries, or do they
so
have consistent geometry?
yeah, so it's both a gel, so they do droplets, and then they do a crystal where it seems like they're all doing a symmetrical same. Although I haven't fully gotten to the point yet of enough of them to start experimenting to see And I suspect they would, like some being 5, like pentagon, some being 6 hexagon, some being 4, etc. Depending on their element crystal shape, that would make sense. But when you break the gel, it does do cleavage, right? So it does the cleavage being how a crystal shatters. So it is both a crystal and a liquid simultaneously in these aerogels.
We
But yeah, figured I'd just hop on and show some of the more recent things that I'm working on and catch up with you guys because love you both and the work you're doing. And Nathan, I pray for your continued healing and that your health gets better and better. And Joe, that your health stays good and gets better. And I'm sorry I have to go as my phone is flashing with 5% here. But
Amen, brother.
love you all. Thank you for having me on. And I'll plug my phone in and be listening. And if I get enough charge and you're on for long enough, I might pop back.
Right on, Bernie. Thank you.
Sounds good, man. It was good to hear from
Appreciate
you.
you both. Much love. Bye.
Okay.
All right. That was Bernie live from Canada.
That was cool, man.
America's hat.
Yeah, sorry. Okay. Yeah. That aerogel stuff's cool, man.
Oh, yeah.
Yeah, he was showing that yesterday in his experiments out there. I should have asked him what he was going to do for Tesla Tech, but he had already gone down on the phone level.
I'm sure I'll be back and want to chime in some more. So
let his phone charge just a little bit. Hey guys,
yeah. If not today, next time. He's always good like that.
I just want to let you guys know we're about 40 days, I think, or so away from Tesla Tech right now. It's on the 12th of next month. And I'll be presenting on the first day on Wednesday on inertial mass reduction. You saw the gravity flyer lose weight. I'm going to present on that. I'm also going to be presenting on the RAV. Basically, kind of give you the understanding of how everything works in the proper order, and then place it into context of what actually is going on inside the gravity flyer to make it lose the weight. So the stuff we talk about on a normal basis, the ions, how they work, how they compress, how they form in nature, what it goes through the plasma. We'll show Sean's, his stuff in there. We'll show Jerome's Lorentz force in there and how that's working out in everything and how it pulls together. And then we'll go right into how it's losing weight because of it, how the ions are sitting on there, where they're hiding at. You know what I mean? Where they're putting on things, and then why it's losing weight versus every other theory out there that's not doing it. That way we go through the whole experience. They understand what we talk about, because there's a lot of this stuff that if I say it, they're going to sit there and not understand it. They're going to go with regular physics and it won't work ever for them. So I have to explain from the bottom to the top exactly where we are, what it is doing, why it's doing what it's doing, and why it's predictable every single time we do it. And then we have to talk about the bounce effect that Joe and I talked about in the beat frequency, and then it's like a trampoline, and how you try to take somebody's bounce and accelerate that again throughout the 5 different layers that are going on in the frequencies of this thing. So we'll talk about that as well, but that's going to be what's going on at Tesla Tech, guys. I'm going to put it all together. I've been working on it for quite a while, and I know it's like an hour and a half presentation, but sometimes you got to go through all the pictures, man, and get it all together and get it in line where you want it. And then the video, because some of the stuff is shocking. Like the very first time that you saw those little dots show out and appear in the RAV, that's like a shocking experience for some people. You know what I mean? They've never seen it. They don't understand it. They see the energy exchange for the first time. They're like, oh my God, what's going on here? And the first thing you start to see is, oh my God, that's Walter Russell. Oh my God, dude, he's showing Walter Russell right in front of your eyes. And this is exactly what Sean showed the entire time. Walter Russell was right 100%. And his periodic table is 100% correct. Ion-based material change. Just understand what I just said. Ion-based, okay, in a negative and a positive vortex is what's working on going in there. That's why his scale goes back and forth, because you're looking at resonance coming up to its peak, and then dropping back off, but it doesn't drop off all the way. It goes into the negative. Then it goes back and builds up in that, and it's an exchange. Okay. It goes back and forth. So we're going to explain that there at Tesla Tech so that they understand it. Trust me, there's going to be a lot more faces that are just in awe. And then I'm going to show them flat out the water and how it works and why it's different. Because if you don't understand energy differently, you're going to think regular physics. And then you're going to be lost on why it works. So one of the experiments I have coming up is using vines as energy, using tubes of water as energy. So people can get it through their skulls. We're not talking about your mom and daddy's plug into the wall, okay? We're talking about a total different energy source. That way they can really wrap their brain around it, and it's going to fry their brains, trust me. There's going to be a lot of questions after that.
Yeah, I mean, I don't doubt it, man. All the work that we've been doing and all the understanding that we've had to, come to have to get to the point. I think it's definitely going to be impressive, and I really think truly that, if we're able to effectively show by then, what we were talking about before and what Nathan said with this positive and negative vortex, two separate things, they come together, and what they do in the center. What they do in the center is the magic portion. That's the part that's dynamic. That's the chase. That's the polarity flipping. That's where all the shit is occurring, and to understand that these things can happen and not necessarily be entirely measurable, but you have the best measurements you could get off of it, and the results speak for themselves. That's not good enough for a lot of people. But when and I think maybe this is where Nathan and I tend to deviate a little bit, but I don't not disagree. You see, he said it himself. They're going to be thinking in regular physics. Now, that's a good thing and a bad thing simultaneously. It's a good thing because nothing that we've ever proposed breaks regular physics, in my opinion. All it does is it makes it a new understanding by connecting things that previously were held separate. Taking multiple concepts that are widely accepted and overlapping, and then connecting them. And you know how I know that this is going to be the issue is because I like to play the mind games every so often, just to see how strong the arguments actually are or aren't, And I'll go into like GPT and I'll decide, you know what, I'm going to argue speed of light with this fucking thing because you damn well know that it's going to tell you that the speed of light is it. It does every single time. It doesn't matter. So I was like, okay, I'm prepared for this argument and it's not going to be a long one. And I said to it, I said, what is the correlation between the speed of light and the Planck distance and the Planck scale? And they're like, well, the correlation is direct. It's in the equation, obviously. I'm like, yes, exactly. I was like, what's the correlation between the Planck scale and geometric dimensionality? Well, it determines the threshold of the, of that. And I was like, okay, so does that mean that the speed of light is simply the barrier speed, the highest threshold of the Planck scale? And they're like, yes. And I was like, and what happens when you exit the fucking Planck scale? And they're like, well, then it's no longer dimensionally possible. I said, okay, that's cool. I was like, so light travels at the speed of light? And it was like, yes, light travels at the speed of light. I was like, no. We can only measure light traveling that speed. So isn't light wherever it already was, wherever its final destination was from its point of emission and propagation all along? And it was like, it fucking broke. It literally was like, you know how it starts writing something, but then it's like, no, and then
Yeah,
you take it
stop.
back, and
Yeah.
it'll start right. It did that 3 or 4 times. At first, it wanted to argue with me about the Planck scale and the dimensional relevance, and then it's like, nope, wait a second, that's a contradiction. We already said dimensionally relevant. Then it was trying to argue with me that, and then the only thing it ended up saying to me was, it's interesting that you say that. Some people think that, but it's never been measured. And I go, well, where are you measuring it from? And it was like,
That's good.
then I brought wave function into it. And it was really, really unhappy because like it knew it was contradicting itself.
Yeah.
And it was losing this argument bad. And it was like, shit. I was like, yeah, what about wave function? I was like, you know how it's like non-manifest while transient? They're like, well, non-manifest is kind of bold statement. I was like, so well, what is it then? They're like, well, it's probability. I'm like, so it's probably here, probably there, but nobody knows why. Because it's not. Because it's not there, and it's like, fuck.
It's
Yeah,
not
you know,
manifest.
right, exactly. No, you can't say where it is because it's probably somewhere. But
Dude,
but then they're like, but then you can't measure that. And I was like, measure it from where?
oh my God. Dude, that whole probability thing is a big pile of horse shit. Okay? I'm sorry, dude. I don't know who created that, but they had too much time on their hands. You know what I mean?
Okay,
Dude,
no. What created it was the math that worked that fit the rest of the stuff.
the math that they created to explain something that was unexplainable because it was wrong.
Well, okay, what's the easiest way to get a math equation to work? Okay, that doesn't work. Just add in an indefinite sum of variables. Doesn't make any math equation work.
Oh, sure. Hey,
You know, it doesn't take right. If it's like, but it could be here, and then that's possible. But then if it's there, then the next, then that's not possible. So then it's just somewhere else. So then that's possible. So just keep on chasing what's possible through an undefined variable that is a probability. You see what I mean? Like it's that's how you solve an unsolvable math problem.
Math is a manipulation. Okay, let me just tell you this because you're not answering the question that you asked. Okay, they're trying to equal something. So all you have to do is take the equation on one side and turn it this way and flip it upside down, and then it starts to equal itself. The problem is it's not equal to each other. Okay, it's in equilibrium. So therefore, the left side always looks different than the right side. They got it wrong the entire time. They're over there flirting with this math just so they can make it work. And you see it all the time. What's that guy that's famous, the math guy that's in physics, that's on everybody's saying Epstein? What's his name? Or
Steve, nobody's gonna get to see the video now. It's gonna be
oh my God, no, not that guy.
not the diddler. Okay,
whatever his name was. Okay, he shows up all the time about math and he starts talking about it, and I'm laughing my ass off, right? Because he's going, okay, so I took this and I took this fraction here and I put it over here, but I flipped it upside down so that I can get it to equal each other. Physics is in trouble now, and I'm laughing my ass off, right? And I'm going, you're a fucking idiot. Yeah, the math works out great because it's supposed to, because you're a math whiz. The problem is as soon as you go to build it, you fall right on your fucking face because it doesn't work that way, because you're building something different on the other side. So I'm laughing at this dude, right? And he thinks he's so smart, and he's like, oh my God, he was on with Terrence Howard and giving Terrence Howard shit, right?
Oh.
And I'm sitting there going, this guy's a fucking idiot. He only understands the math, and because he doesn't understand anything in how it builds, he'd never understand the exact way that things work out. This is a problem with a lot of people that do this, okay? A lot of the debunkers out there. I go over there and I watch this, right? And they're talking about carbon dating. Well, what is carbon dating? It's the last time that a carbon was inside of a pyramid, okay? And they say that dates the pyramid. No, it was the last time that the carbon was present in the pyramid. Now, if they took the pyramid apart and they took a layer off of it and there was a leaf in between the layer where you can't get it in there any other way but to do it at the time it was built, then you would have carbon dating that's accurate, okay? Because then it would make a lot of sense, but that's not what they're doing. They're taking the carbon from the wall, Well, the carbon from the walls, the last time somebody had a barbecue inside the pyramid, okay? The last time that they had it open. Just understand how stupid that is. You're telling me that the date of the pyramid is based on somebody's time to have lunch in the pyramid at some point, any point in time, is the last known time that somebody was in there. But it's not the time that it was built, okay? Because you cannot carbon date stone. That's the problem with this stuff. And they're all talking to each other, blah, 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 blah. I got the right point of view. No, you're both full of shit. You're both full of shit. I don't care what century you said it was in, you're fucking wrong, okay? Because you don't have the right answer because you cannot carbon date stone. You have the best hypothetical answer that you can have. And you arguing about it as two fucking women, bunch of little cunts, man. Just shut the fuck up. Just shut the fuck up. You both don't know what the hell you're saying. I hate that shit.
So here's the thing, and this is where math gets mind bending, and so it becomes simplified and indefinitely complicated simultaneously, because realistically everything can be summed up to, three factors more or less, like it tends to be. You have zero, okay, zero, and then you have two interactive fractions on either side of that zero, and I always got blown away because even though the show annoyed me, I still watched it from time to time, like young Sheldon, right? Like like Sheldon from Big Bang Theory, right? And I remember the best episode that they had on that was actually, it broke my mind at first until I realized, wait a second, these guys aren't as fucking smart as they're trying to be, even though they probably consult like real fucking scientists, and they can think. But they had this whole episode about zero doesn't exist. And I was like, then they went through all the reasoning, and then it went to the professors, and they went through all the reasoning, and I was like, that's a good point. Until I expanded my mind further in actually thinking about it, and I was like, no, zero does exist, because zero isn't nothing. Zero is the ambient, the least the representative of the least of an ambient average of a local system. Okay. And what that means is that there could be something less than that zero, and there could be something greater than that zero, but if something falls at that zero, okay, it actually is at that ambient, least point, where on one side you have a positive, and that's the whole entire cause of duality, positive and negative. High pressure and low pressure. Well, what's the differentiating factor is the ambient zero of what the ambient, right? So in order for a pressure to be a negative pressure, that means that there has to be some ambient where the equilibrium rests. Now, the thing about the equilibrium is, since it's the sum of the whole system, okay, as an average, it's also the high average too, which goes to show why zero is representative of infinity. And goes to show as well why the barrel being completely empty is exactly the same as the barrel being completely full. And I've said that analogy many times, and I know that's hard for a lot of people to get their head around. But, because that represents the whole entire system, right? And then you have a counter on either side of that, plus or minus, that becomes the differential that then goes into a state of exchange. Okay, and what does the two sides equal out to? Zero. That's what it boils down to, and that's always the point, like, because it goes to infinity on either side.
Yeah,
it's
well, math is all about the question you ask. Okay, so if you ask, is there a multiplier? You know what I mean? They'd give any more to this thing. That's the question they usually ask. And the answer is no, that's why they put a zero. Okay. But that's not always the question they're asking in math. Okay. So 1/2 base times height is a triangle. That's what Terrence Howard was coming up with. And he's saying that you can't have a zero on each side. And he's 100% correct. Okay. Why? Because there's always something there. There's always a length going on there. And this dude, whatever his fucking name was, is over there giving him shit about it. And I'm like, dude, you didn't ask that question in math, and you're over there trying to, bully him. Let me just tell you something right now. He's right Terrence Howard is. And why is he right? Because he's talking about Walter Russell the entire time. And it's something this guy just didn't understand. The geometrical patterns that he's putting out are the exact geometrical patterns that what's her name comes out with. Okay, that little loop that's always in there. Well, it's always showing. Well, our solar system does that. Every planet goes around and goes in the loop, and then it goes around, goes in a loop, and then it goes around, and it makes on the points of it makes a geometrical pattern at all times. Well, hello, that's in there. That's absolutely there. What is it? Weinstein? What did he say? He goes in there and he goes, "Oh, no, you can't have this. All right, specific name for it." Well, shove that right up your butt, dude. I don't give a. Did you even listen to what the man said? That's what bothers me about it. And then you get in there and people like that Professor Dave, the big twat that dude is, he gets over there and tries to debunk everything. And that guy's the dumb as a box of rocks, dude. If it wasn't written on Google on his search, he couldn't figure out what the hell it was. That dude couldn't find his asshole with both hands and a treasure map. Okay, that dude is a fucking idiot. Okay, look, that's why I dislike this stuff. It's like, dude, if you do the experiments, it tells you something different than what you get and regurgitate from the book. Okay, you're reading a science book to me instead of doing the experiments. You're taking it based on what they assumed what was going on. Perfect example of this. Okay, just so we understand this, an electron test. You know what it is? It's basically a wire inside of a bottle that's had a vacuum pushed on it. And all it does is this. It goes up and it goes down. It goes up, it goes down. It pulls a negative force on it, right? Well, as soon as you put it inside the bottle, what did you do? You suck the air out. You put ions in there, so that it's basically creating one way for it to go. And they say it's an electron. There is not a fucking ball on that entire experiment, okay? Not one. Not anywhere to be seen, okay? It is a movement of a field, okay? The electromagnetic is a field and it moves, okay? That's it. It's a linear part of the equation. They don't understand that. So they write it as a ball because mathematically it works out for them. So they see balls and everything, okay? There's balls here, there's balls bumping together in the wires, okay? It's fucking stupid, okay? It doesn't exist. And then now they get to, oh man, maybe it's a field. Maybe it goes on the outside of the wire. And now ChatGPT starts agreeing with you and starts saying, oh yeah, that's what they see it as now. Well, hello, how many years of physics do they go through telling us it's balls? How many times do I have to see the same stupid thing of, oh, this ball, this ball, this ball? Why? Because you didn't understand it properly, okay? It only makes a ball when it presses into a 360-degree event where ions are in the center, okay? Other than that, it's a flat field on a flat line, okay? And it's not even flat, dude. It's swirling around it because it can't be in non-motion. That's why that whole plane thing in the magnetic field, and they do the little slices, it's incomprehensible that somebody thinks that works. Where in the world does that fucking work? It doesn't, because you know why? Because you have motion. And you can't have energy without motion. So this little flat line that sits there, it doesn't work at all. Okay? They say, oh, it's a magnet. It's a magnet. You put a magnet in there and it creates field. Well, magnetic field looks nothing like that. Okay? Magnetic field swirls around it, and corner spins around it. It does not make a flat plane with it looks like a target. Nothing does. That's why making your experiments and learning what they do is so important, because you get imbeciles that like this, put this in the textbooks, and this is what we all have to live with. And I'm looking at it going, we're a bunch of fucking retards. God's looking down on us and laughing at us, okay? Just flat out laughing. You know, look at these fucking bunch of retards. Can they turn the doorknob today? Or they got fucking grease on their fingers, okay? It's insane to me how they think these things work. It's like, let's just create something besides the atom and we'll go smaller, okay? We'll just give it some fucked up name, okay? Oh, yeah, no, that's a Harrytron or whatever, okay, that they come up with. That's what they do. That's what they get paid for. I'm sorry, guys, but you know what? These people are morons. They have no understanding because they lost the ability to do experiments years ago. And then when the right experiment comes out, they start fighting it like morons. You can't create that. That lab is not possible. You have to have it in the vacuum chamber. Oh, really, buddy? Let me put it right in front of your face. I love doing that, dude, to debunkers. Let me just come on and do it right in front of your face.
All right, you want to talk about what idiots everybody is, and just and also
Joe, you're cutting out real bad.
I'm gonna feed the rigor in the chat there, Yoni, bringing up 369 a couple of minutes ago, because you know how I love my 3, 6, and 9. But I want to just explain this very briefly. So
Joe, you're cutting out really bad.
Am I? I'm sorry.
Yeah, go out and come back in.
Can you hear me better now?
No, it's lagging hard, bro. Sorry about that, guys. Let me make sure he gets out his point. Sorry, I talk about this stuff, dude, because it irritates me because I actually see it right in front of me.
Yeah. Is this better now?
Yeah, you're much better, dude. Go for it.
Okay, yeah, I just turned my Wi-Fi up. Okay. So, all right. So what I was saying before is if you want to ever show how stupid people are and how they really just don't have it figured out as to how simple it actually is, even though it's kind of a little hard to follow. All right. And again, I'm going to feed the egregor in the chat, and I'm going to give Yoni one on the 369. I don't want to go super deep into it because I've already kind of talked about this, and I'm sure most people are kind of sick of hearing this, but very brief explanation. Okay. When you're following, a Rodin spiral, okay, or the Rodin math, okay, through 3, 6, and 9 sequencing. All right. What you realize is you have your cross point creation of a third vector through a 4.5. That's initiate of a +1 to the 9, which steps a 9 count up to a 10 count on the third vector. Your third vector is the magnetism. Okay. Now, what I want you to understand is that once you bring the 10 factor in, okay, that changes that 4.5 virtually because of the pulse that's occurred, right? It's an offset B frequency. That changes that number, okay, to the mutual average between the 9 and the 10, which is a 4.75. Now, when you have a 4.75, and you look at that number and then you look at where the 4.5 ended up plotting out, it's at 4.75. It's not dead in the center. It is south of the center. Okay, it is at 4.75 when you plot it correctly. Now, why is it significant? What does it mean? And why the fuck am I bringing it up right now? Well, if you take the two systems, remember what we were talking about, two systems interacting, looping, and having a mutual reaction, okay? You get a sum of 19 between the 10 and the 9, okay? And when you divide the 19 by 4.75, you get 4, okay? 4, flat and even. You get quadrants. Okay, now if you break that dimensionally up into the next level, meaning you have to bring it up one dimension, okay, by doubling it, now you have 8 quadrants opposite one another. That's what that would do. Okay, now think about any stable sphere that you have. Okay, what you end up with is 2 crossing lines in the middle. You have your, your meridians, and then you have your equator. Okay, you have north 4 quadrants and south 4 quadrants. And when you bring the electromagnetism of that sphere into account, the cumulative sum of all the field dynamics in which exist, you end up with convection. North and south convection, east and west convection. Okay, you have eddy currents of convection occurring in these stable sphere patterns. Okay, and they're north quadrants and southern quadrants for a total of 8. So now you can see exactly how the 369 works, forms, stabilizes, collapses, changes some of both and how they form and then how they act off of those dynamics. Those are the numbers, those are the mass, those are the ratios. You look at the initial configurations and the secondary result of that initial configuration, being that third vector, the pulse pattern of the magnetism, is all energy vectoring. When you look at what the energy flow is doing at any given number, and then you look at it, those numbers, relationship to each other, and then relationship, sum of the whole, you end up with exactly the ratios which are required to get the necessary thing for the stabilization. Period. If you look at the fucking way it works out and exactly what I'm saying, and you understand this fully, the answer to everything is right there. That's it. What do you need on this side versus what do you need on that side? What is the sum of the two? Because the sum of the two is not just this plus this, it's this and that offset by one another on a positive side, a negative side, and then a step up in a count pattern. Okay, so there's two sets of ratios going on. There's the thirds going on, and then there's twelfths. I'm sorry, not well. The 12th is not the 12th. I'm sorry. You have derivatives of 3 and derivatives 2. And that's what it boils down to. The funny thing is, you need to start with the 3s to get to your 2s.
Okay.
So everything's born out of that, man.
Real quick, shout out Ulysses, man. Thank you very much.
Big thank you, bro.
Hey,
20 pounds sterling.
I want to say this because Joe made a good point about the eddy currents. You know, the eddy currents are where the vortexes come from, right? So think about this, and I've done this with my Rodin coil. Okay, you take the Rodin coil, you put it in there, and you put the ions in there. What happens to it? Okay, we start to get a flow pattern that goes through it. So when I pull the wire from the center of my Tesla coil, it stays on. Now I've done this with that coil, with flat coil, stuff like that, and I show you that. But with the Rodin coil, it's special. Now let me just tell you something that goes on here that you're not understanding right away. Because it's all cold energy, it needs heat. It needs a draw. Where does the draw come from? The exact place that Joe just described in the eddy currents that come out of the Rodin coil itself. That's how I'm getting the heat on the outside. That's entropy. That's creating the heat zone on the outside with the cold zone on the inside, giving me an entropy reaction that's going on inside of the system. That's why it contains energy inside of it long after the energy has been turned off. Understand this. It's structuring the environment and the gases around that in order to create that, because I'm creating eddy currents in it, and I'm taking ionization and I'm using entropy in the system in order to contain it. It's basically a giant open air capacitor that's flowing, okay? And as if you can understand that, then you have the whole ball of wax right there, okay? That's the system. That's the one everybody's looking for. That's the one we put in the gravity flyer. That's the field system. That's everything going on. It's a simplified version because you don't have to account for different things and mechanical things going on. It's simplified because the energy flows naturally through the center, like Joe said, right through everything, and it's in eddy currents out there to heat it up, cool it down, heat it up, cool it down, and you've got an exchange rate going on. And then eventually when you get to higher state of energy, why it's cold, and this is why superconductors work, is because the more energy there is, the less light and everything is expelling out of it, which means it has a higher form of energy on the inside. Therefore, it's superconducting. Therefore, it's cold. So when you see the MEG, when you see other experiments go like that, they start to turn cold on you and they start to freeze over. The exact reason why is because the entropy in the system is allowing it to flow properly in a very high state of energy with a very low amount of heat on the outside. That's why I tell you, heat's not something that you want. You don't want the amps in that type of a system. You want the voltage.
Yeah, I can't argue with the damn word you just said, bro. And that's exactly, and it's right. And what is it? It's two different things. Their interaction, and then the interactions which you have to look at. You look at the two separate things, you're just going to be stuck there. But you see what they make, and they make something, but then that makes something. Oh, wait. What the hell? Wait, isn't that what we see? When the two things make something, but then make something, this is what you have. It's like, it's cell division, man. It's multiplicative in its nature. It's, it's fractal, and it's diffuse and non-diffuse simultaneously. This is the entire point. It's like when you break these things, you look at it and you say, oh, look, it's all going into a state of diffusion. It must be wafting off, but it keeps going. All right, it just keeps going into a state of diffusion. Like, What, until it runs out? I mean, everything runs out, right? Well, I mean, yeah, but it's hard to say that when, like, the car's driving on the highway, but somehow, like it's getting filled up as it drives, then that's sort of the point, because it comes back. And as long as that stability is maintained, that's a high efficiency system. That means that the losses are minimal.
Oh
That
yeah.
means that you're not actually losing to diffusion, because you're still getting back. You're just not seeing where it comes back.
Well,
And that's always the thing, because the creation of potential is done generally in a quantum state, as they call it, and because of that, some of it's recognized, but not the full extent. You know, that's it.
well, let me tell you why it turns off. Okay, this is a very interesting factor why this does it. You're in equilibrium with the Tesla coil itself. As you connect it through the rod down the center to the actual Rodin coil, your connection is this system over here in the Rodin coil is interconnected with the Tesla coil. It's getting the resonance values from the Tesla coil to put into the Rodin coil. Okay. So when you turn one side of the system off, this side of the system will eventually turn off. But what happens when now the systems are in one system? You see, that's where you get runaway. Okay, that's where you get the over energy states. See, we're controlling it from the outside right now, but because we're collapsing the resonance inside of it by turning off the Tesla coil, we're collapsing the field of energy. Now it takes longer to do it because we did it right. But what's you need in there to sustain this is for the energy to be in the coil itself. That's why when you see UFOs, you think of a hole in the center. You get what I'm saying?
Now this is where you use, and this is when you leverage what they consider to be the downfall, right? Because the whole entire problem with excess energy, cascading effect, runaway, right, is high density energy levels in material, right?
Mhm.
So what you need is you need high potential in a state of diffusion around your material, and then the material is the vectoring path that's self-modulating its maximum efficiency and capacitance, and you can do so more effectively through resonance, meaning that if your potentials at a certain cycle, certain frequency base, okay, by matching that frequency base, there's coupling that occurs. The resistance is not there, therefore the heat is not there, and it could stay in a state of much what you get is a serious raise in capacitance, but because that capacitance is in a state of unvectored potential, it's not necessarily something that you could just test and see. You actually have to put it to work.
Yeah, but that's the thing, Joe. This is why I say the heat's a bad thing. The magnetism is a bad thing. Okay. As soon as you have magnetism, you have heat. Okay. Understand this. Heat is loss. It's
No,
hysteresis. It's the
magnetism has
loss
to be the outer fields have to be the magnetism.
to be the containment. Yes, but the
and
containment
and
can be
the,
very low.
and you
The
have to be
higher.
inside of you have to be on the inner geometries of the greater magnetic field, and everything will have its smaller magnetic field in unto itself as part of the larger piece,
Right,
but
right. But that's what I'm saying.
you don't want it dependent on the magnetism itself. You want it to be dependent on the whole,
So
the sum of the whole, not the sum of the
let,
small.
yeah, let me explain it this way. The mag is magnets. They call it cold current. Okay. This is where they call it magnetic flux. Okay. Because they're just taking the magnetics from one side and pushing the other. Okay. And by pushing the other, they're doing an energy exchange, Joe. Just that's all it is they flip it to one side and the magnetism's here. It has a little bit of heat to it. Then they flip it here. It has a little bit of heat to it. Then they flip it here. Okay. They're doing an energy exchange between the two at all times. Okay. But what does that mean? They're creating a higher state of the cold energy on the inside, which is the ion layer, which continuously goes back and forth and creates the energy in a cold vector, which is much more powerful than the actual heat that they have on the outside. Therefore, when they talk about the Meg, they're talking about a very small amount of heat, but that's all you need. That's all, just enough to create the layer. That's all you need. Because what happens with ions is they like to bundle together. They like to pool together. That's why if you have an open hole, ions that go in there and pool in the open hole. It's the whole way it works, though.
Right, and I don't disagree that it only has to be a small amount of heat in certain circumstances, because the truth is that you can't have no heat, because then you lose your differential.
Just enough for the outside barrier.
Right. Right. You see, something being cool is not but for heat. See? And that's the idea. And in order for there to be a chase and an exchange, therefore stability, you must have the opposite side of the coin. And that's really it. It's just about taking what they already know, which is entropy, right? And more or less, it does boil back down to entropy all the time. You're basically just taking that and you're just using it to exploit this. And once you realize that all heat is anyway is interdimensional energy exchange signature, and then you take it to the other level of thought, and then you realize why that's time dilation, why that's gravitation manipulation, why that's time travel, why that's all these fucking highly weird and esoteric sorts of exotic topics of conversation. It starts to make complete and utter sense, because they say it themselves that this is just naturally what happens. So if you take what naturally wants to happen and you're just directing it, and you're controlling fucking reality at that point. That's it.
But that's why they came up with Planck's distance, okay? Because they couldn't understand the exponential amount of energy that goes on in a system, so they had to create Planck's distance in order to understand it. So as soon as you understood that, you knew that you had a compression of energy going on they could not explain. Okay?
Exactly. Well, because the heat signature being in that means material has reached high enough excitation that it's lost its pure energetic potential, and there's no way to turn heat itself into an electromagnetic energy. Okay, heat is not electromagnetic energy, but it's energy. So you have to realize, well, where did the electromagnetic energy go? Well, it went back with the material. The material is gone, and what's left is the heat. The heat is the signature of things leaving 4D time, into the fifth dimension. Because again, all the fourth dimension is it's a permeability equation of 3D. It's pressure. You talk about torsion layers, boundary layers. We talk about this shit all the time. It's like probably the main theory that you have on everything, and I agree with you, but it's definitely like a main point of your focus in these technologies. That boundary layer is exactly what 4D time space is that pressure that we exist upon in 3D, and once you cross that threshold, it's into 5D. So that heat is the signature of that occurring. And
well, it's funny, Joe, because we do Tesla coil experiments a lot, right? And I don't think people really understand this, because the first question I get is, "What's the amps?" And I'm going, "Well, it's irrelevant." And they go, "Well, yeah, why is it irrelevant?" I go, "Because it's in resonance. As soon as they put it in resonance, the impedance is gone. That means that the amperage is irrelevant, because it doesn't stop. It doesn't slow down enough to create the heat that you need." Okay.
Hold on. I want to interject here, because I think this is going to fuck people up. Why doesn't the Tesla coil do that? It doesn't, because it puts it off as radiant energy. Why does it put it off as radiant energy? Because it is self-modulating its capacitance, because it's overcapacitance And rather than have a material failure, it's literally projecting that energy outward as it increases in its voltage and drops in its amperage. And with the amperage drop goes a resistance drop and a frequency increase. And that's, you know, when you look at it from the primary to the secondary and its transition upward, okay, that's realistically what you're looking at, especially when we're talking about, as Nathan would call it, not a bipolar setup, which as I say, there's no such thing as exactly not a bipolar setup, but I digress. The whole idea here is that there's a difference between the bottom and the top of the of the secondary coil as far as its voltage is concerned. Okay, and as you get up to the top, okay, it's actually equalizing itself through this radiant discharge. Okay, this is why it doesn't get super hot. This is why you don't get the material failure. But if you were to take the same exact energy levels and run it as a current, okay, and you were to run that current through a wire of the same diameter, you'd have total material failure.
Yeah,
because there's right, because aside from the spiralytic vectoring of the current that's flowing up, you also have this interlayer interaction too, because the wires are that close, right? And that increases the capacitance by exponential amounts. But it also, when when there's an overcapacity in any given region, okay, it repels and rejects that overcapacitance and expels it as radiant energy. And we've never really explained it that way. And that's contrary to what you might think when you understand the magnetism of the coil, because the magnetism of the coil is built out. So it's in the inner field. So there should be compression, aka it should be compressed and held in to overload, cascade, and fail. But it doesn't. Why? Because it's not affected, because it's in the inner geometries. And as they said in Edda Dorpa, an antiquated book of science fiction, as they put it, from 1895, right? If you were to drill a hole to the center of the earth and fucking jump in it, okay, you would accelerate about 1/3 of the way down, okay? And then you would start to slowly slow down. And then all of a sudden you'd get about 2/3 to the center, and well, then you'd stop. That's it. It's a gradient. It's a diffuse, but it's a threshold nonetheless. So there's a turning point. There's a point where the polarity flips. And this is these ideas are exactly the same. They're exactly the same. They work exactly the same.
So I want to explain something. I just want to shout out Gutters. Yeah, I agree. Anyway, I want to say this so that people understand this, Joe. We talk about the magnetism in a coil. We do realize at this point, you just said that it's radiant, right? Therefore, we know it's radiation. Therefore, we know that you're creating a sheath layer, not a magnetism layer. Now, understand the process in your head you have to go through. Tesla coils are non-magnetic, okay? They create a sheath layer, and that sheath layer creates a boundary. That boundary creates a radiation. It's the Van Allen belt all day long is what it's doing, okay? If you want to see something to visualize it, that's all you're doing, okay? That's why the radiation only gets to a certain distance, because the environment pushes back upon it and won't allow it to go any further in distance because you don't have enough power in it. That's why nuclear weapons go off and they pull out and they push back in, because the environment doesn't allow it, okay? It's like a bouncing effect. It pushes back against you at all times. Understand this. This is why when people say it's static electricity coming out of Tesla coil, I laugh my ass off, right? There's no fucking chance in the world, okay? I've been there. I've done that.
It's radiation in a state of potential.
Yes, so hold on. And Joe's done this, and I did this to Bernie, okay? And I'm sorry, Bernie, that you were a victim of this. We sat there and put the energy in, right? And I put it in the oranges, right? And I cut it in half, and I showed him. I said, look, the field's right here in the center. And I sat it on top of an aluminum plate. So he goes over and puts his finger right on the aluminum plate and burns the living daylights out of it, right? He's like, oh, what the hell? And I go, turns it off. I go, now put your finger back on it again. He put his finger back on it again, and it was cold to the touch. And I said, the only way you get that is radiation. If it was static electricity, your hair would be standing up and you would have got a little zap, right? So it was just funny to explain the difference because people who read it in the book think it's all this static electricity. And then people who are in there in the environment who burn their fingers all the time are like, that's not a chance. That's static electricity. Because my hair never stood up. It just burned the living daylights out of me.
Yeah, no, static works differently because it's a state of potential in an unvectored accumulation. You know, and the thing is that this isn't that. Anything that spirals does this, okay? And it's exactly what I was saying before. If you take a hose and you blast it around the edge of a bucket and you get it to swirl, okay, what you'll realize is that you'll get laminar flow in this vortex, but it'll have sort of instabilities as far as the volume of water in which it's able to stabilize in that laminar flow, and it'll actually eject that those droplets of water from that laminar flow system, so it stays completely stable. But if there's too much, it tries to autocorrect by throwing off that which it can't stabilize. And that's exactly what's happening, and that's the idea with the capacitance, because that's capacitance as well. That's that's a voltage equation because it's a flow rate, right? I mean, even though it doesn't flow, I mean, it's still the idea. It's a pressure, right? So there's a certain amount of volume under a certain amount of pressure, and deterministic of the material, the pressure and volume, okay, is good, and the viscosity of that material, obviously, right? That's going to be deterministic of how much it could hold together in a laminar circumstance based on the angular interaction of the propagation, which is what it is, the propagation and the point of angular interaction with the material. It's all the same, people.
Yeah.
It's all the same. This is exactly how it works.
Check this out. I got to tell you this because you hit on a very important point. Capacitor bank, capacitance between the coil, capacitance in the air. Understand it's all part of the same system.
Oh, yeah.
Why would you use a Tesla coil for anti-gravity experiments? Because of the capacitance in the air. Now think about that. It's coupled to the capacitance of the coil. If you stand in the field, you change the capacitance of the coil. It doesn't work the same. If you're outside the field, it changes the capacitance of the coil. Okay? You're literally moving yourself in and out based on the capacitance. If you touch the light bulb while it's on, it changes the capacitance of the light bulb because you added more capacitance because your body's a natural capacitor. Okay? Understand what's going on here. Okay? Why would I use something like a Tesla coil in order to create the zones? Now think about this. The outside zone, it fluctuates, right? I need a heat layer on the outside. Okay, the little bit of heat comes from the outside of the Tesla coil. The inside of the Tesla coil is completely cold. Okay, it's the ionic layer versus the magnetodielectric. I have two of the layers I need, and they form the strong field. Now understand this. Okay, T.T. Brown. Two weak forces create a very strong force. What did he mean? That when you have a magnetosphere and you have an ionosphere, it creates a boundary layer. The boundary layer is the strong layer, okay? Two weak forces create an extremely strong force. That's exactly why you need it for field dynamics inside of any kind of craft, because of that exact relationship. Understand, you saw it the whole time. You saw the Tesla coil do it, okay? What did you not see? That when you turn this thing on and you put the field on the outside, okay, you're spraying DC voltage, right? It's coming off everywhere, it's setting off your computer, ding, 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 all day, right? You turn on that Tesla coil with the wire on the inside, what happens? It all shuts off. Everything stopped making noise and it started to contain the field. I have now created the perfect boundary layer that will not allow the energy to pass, okay? Just understand that. So when you get to an understanding of a Tesla coil, you understand, hey, we got something different going on here. Why can't you use other things to create it? Because it's not doing the same zoning, because it doesn't create a high enough radiation field that's going on inside to accumulate energy on the outside of that field, the Van Allen belt. Okay. Why do you see massive accumulation of radiation materials in there? It's because it's a boundary layer that will not allow it to go further than that. Now we understand why it's so important when you get into field bubbles and why they work the way they do in the environment that we're in, because it's literally structuring the environment around it. And it did it from day one on the Tesla coil. Now you understand it.
See, when I proposed a gravifier design that's yet to actually happen, right? The whole way that that design was made was based off of utilizing asymmetric energy exchanges at both sides of the energy, creating multiple vectoring paths internally and inversely externally, and then having those exchange as well through all the concepts that we've discussed. And it really connected the dots, right, between the things we talk about and then actually seeing knowing what each thing does and being able to observe those effects and then being able to show the relationship and interaction of those effects, building out those fields exactly that you would expect. And for those that don't know what I'm talking about, I don't have the drawing on me, but I'll give you just a generalized idea. Okay, it was a Tesla coil with a primary on the bottom. Okay, and then it was an aluminum plate. Okay, that circles around the Tesla coil with a with a insulator in between that. Okay, at about just 1/3 the way up off the primary coil on the bottom. Okay, then it was totally encapsulated in aluminum around in a disc shape. Okay, to be able to keep the eddy current flow patterns. Okay, because what you want is you want the radiant energy to come off and the magnetism to come off, interact with the dielectric of the aluminum, and then cause the eddies to go on the inside. And then you'd run the center rod, down the top and the bottom, and separate them with a ceramic disc in the center. And you put the bottom piece to the bottom of the plate, and the top one would just lay just straight above it. That would hook up to the top and bottom of the craft. That's the aluminum shell. And then you would have an insulator around the outer circumference where the top and the bottom shells meet. Okay, and what would end up happening is, as it builds in the capacitance on the inside, the energy level, and then build static on the outside, top and bottom of the shell. Okay, what you'd end up with is a pull over the side through the insulator that separates the top and the bottom. And through that, you're taking a DC, in the state of potential that's being pulsed out in, sequence by the Tesla coil. What you'd end up with is adding resistance to that, but still now making a circuit to the bottom. That would ultimately lead to an AC alternating a current, a sine wave off of that to connect it. Well, that goes right back on the inside, and the same exact process that's happening on the outside is now happening on the inside to try to pull together. So it's pulling the cathodic energy through that insulator, and then, what's going to form in the center of that Tesla coil now? A RAV.
Mm-hmm.
So you'd get a RAV in the center of the Tesla coil, and you'd get around the center of the craft, you'd get a plasmatic glow around the edge, kind of as the energy levels go, and then the magnetism of the outer, a whole system grows out in proportion. The static state would continue to build as well in a state of density, dense toward the shell, and then diffuse out. That diffuse charges the frigging environment, okay, and then brings it in. But then as it hits the higher density levels, pushes the environment away.
Hmm.
And the whole entire system is going like this.
Mm-hmm. Makes perfect sense.
Yeah. And what is it? Well, it goes right back to what I said earlier. You have a north and a south broken up into quadrants, and you have it all eddy currenting around and feeding each other. And then that builds out, and then that builds out, and it's the flower of life. So, and then it goes from, 4 to 8 to 16 to 32 to 64. And then it just goes out in that fractal diffusion. And that's exactly how it works. That's
Nice.
exactly how it works. And I know it's words and not pictures. And I know not everybody could just listen to me ramble about all these abstract concepts and esoteric things that we made up as far. You know what I mean? You understand that we've made up half of these terms and shit because we, I say we loosely. I mean, really, Sean. Sean is the inventor of the RAV. The RAV was pretty much an unknown thing, so therefore we've had to create these dialogues around it, right? So I know it's got to be hard to follow that and then envision exactly what I'm saying. But for those of you that can, God bless, because bro, that's the answer, and that's actually how the planet's built. Guess what? That's how the planet. That's how it's all done. That's the RAV in the center of the Tesla coil is the core of the Earth. I don't know how else to put it.
Let's see if we can't make this a little easier, Joe. I want to shout out Sean real quick. He sent me some bismuth, dude. So we have an experiment coming up. I have round Tesla coils, right? So what did Sean do? He took basically an AC flyback, ran it in, it had water in it, and the water put off a field that bounced back. Okay. It created a zone off of where the bottom was because of the bismuth. Now, let's think about this in the correct way. If we have bismuth to the core and then we create water around it and then we put the Tesla coil around it, okay, the Tesla coil is your slosh. It's your AC flyback going back and forth, because we're going to do it bipolar, okay? As soon as you do that, you're going to have a reaction. And here's the reaction you're going to have. You're going to have a sheet zone that builds around the Tesla coil no matter what. And it's going to go out in layers of frequency, okay, as it builds out. But what's going to happen on the inside? The inside's going to push it in, and it's going to bounce back out and go with the same exact layering that goes on in there. What's going to happen is they're going to double layer, and then you're going to create the boundary zone on the inside, and you'll automatically have everything. Now, what's the understanding of this? If I took it out of the center and I put it in the walls of the craft instead, and I used aluminum, bismuth, aluminum, then what would happen to everything? Well, you have to have a water layer in there in order for this to work properly, okay? That's number one. There's got to be either on the outside, inside, or whatever. The inside would turn into a Faraday cage. The outside would turn into the field dynamics that go on, okay? It's pretty much that simple. The hard thing is when you do it with the Tesla coil, you're going to have a zone where you cannot be, okay? Which is fine, okay? Because we're doing it on a test bench and we're not doing it in a craft that we're going to fly in. So creating the bismuth at the core, the water layer, and then the outside Tesla coil layer works perfectly in order to create the sheet zone that's going on. And it should work as an energy core to a craft and make it so that I can lift this thing and have atomic weight loss going on inside here. Atomic mass is reduced inside this craft as soon as I do it. Okay? That's the simplest understanding I can possibly give anybody with the correct material, because you've got to understand this. Diamagnetic, paramagnetic, okay? And then you have ferromagnetic. Why? Because that's exactly how it keeps building out. Ferromagnetic on the outside. That's your magnetosphere, okay? Paramagnetic, that's the boundary zone, okay? Diamagnetic, that's the inside ionization layer, okay? They work out perfectly because magnetism is based on the sheath layers they create going on in the environment of the Earth's condition. Therefore, it'll build out that exact same way, which tells you the inside core is mechanical in the way that it has vector direction, and they change the vector direction in order to release pressure. That's why it's working, guys. This is the whole ball of wax, and this is why understanding it matters, because now we can build it properly.
See, and this is why the rock that I had was strange, is exactly what Nathan just said, because the rock, as far as I know, and as far as my observations were, was a multiferroic spin liquid. And spin liquid is directly related to moments of excitation pertaining to magnetism. So if you have a multiferroic, multi-magnetic mode, that means that you have a completely modular electromagnetic system capable of any vectoring and any magnetism based on external or internal or random or purposeful moments of excitation based on molecular arrangement due to unfixed portions of a molecular arrangement in a cogom lattice structure because of the very nature of the cogom lattice in itself, and why that geometry is so radically important and why that geometry is so omnipresent. On the large scale and the super small scale. We're in the weird scale. The weird scale where, we're the result of the small and the large scale. So we talk about these energy exchanges. Here, see how I'm saying it's all the same. It's all the same. It's like I'm just explaining the same shit over and over. You have this hyper small particle and energy scale, hyper small, and then this huge, solar system, galaxy, universe scale, and it occurs there and it occurs there. And then we are that thing that results from that interaction and this interaction. And because of that, you don't really get to see those fundamental little things happen unless if you recreate the same conditions in which manifest both in the first place. Okay. And because we're the result of two things, right, that are equal, that are opposite and kind of equal in their own regard, both zero and infinite, the sum of all, right? It tends to be anomalous to have the sum of a localized mid, like this scale, system that equals that relationship. But that's when you recreate that relationship, this is what you get. And that's the idea.
Yeah,
That's the fucking idea. that is it.
Red shift, blue shift.
Red shift 1, 2, 3. Red shift, blue shift 1, 2, 3.
Just as simple as that. I mean, the energy exchange, you see it in black and you see it in pink. Why? It's red shift, blue shift. What's the difference? The amount of energy. That's it. That's why you're not seeing it that way. When you blow a bubble, you still got red shift, blue shift going on. It's the essence of a sphere that goes on that creates this phenomena that happens inside of it. Because as soon as you create a prism, you have red shift, blue shift. And that's all it is.
And the red shift, blue shift is exactly it, because where we are is in the green. We are dead in the middle. We are in the green. And the thing about green is that, pure red and pure blue don't really exist in pure green. They, and that's why it's hard to bring those red and blue into green, simultaneously. It's like because you have to push the green out in order to have the red and the blue. That's the analogy here, like you have to push it out, and that's what we keep on saying. Get these things, it needs to push out that zero. It needs to change that zero, that ambient environment, that sum of whatever the whole is. That zero needs to be the sum of two other things, just not the two things that are naturally ambient.
The green defines the black. Every time Sean shows it and it shows up in green, there's black, structured black environment going on. And just understand that for what it is, the higher state of potential that's going on inside of the black right there, because it's not losing energy to light. What happens? You start to get green around it. That's a special state. Now, UFOs, and you guys all talk about that all the time. Where do you get the green from? You have to create that certain state. What does that possibly mean to you? This is why it's so funny to me, because if I tell you I'm compressing ions to the core, I'm creating that special state. And if I'm creating that state in darkness, what's going to happen? Green. I'm going to get green.
Tesla said it. He said he called it gas rarefication anomalies. All the craziest results he ever didn't publish, but he wrote around. Like he wrote it. So when you read his actual experimentation, he writes around the actual anomaly most of the time. But he gets very excited and tells you about things like the green gas, and then he explains the setup in which it occurs, and then the result is the green gas. But you're like, wait a second, that's the byproduct of other things. And that's the shit that was in his trunks that never got published, and that's just kind of the reality of it. Gerald used to say it too. He said green gas rarefication. He's like, that's when you're in money, because and Nathan's right. You separate your red and your separate red and your blue. You get your green frequencies dead in the middle. That green frequency is the result of the red and blue exchange.
Yes.
And then that means that where you have that offset equilibrium state, and people will say, well, red and blue don't make green. Yeah, they do. But and then on the other side of that green is exactly what Nathan's saying. If you have an equilibrium exchange on this side, you have the non-equilibrium exchange on the other side. That non-equilibrium state is the low energy state. As you would kind of, but a very high potential of low energy. And then, that is absent. It's dark, right? It's there and not. It's there and not. Like, I mean, that's it.
Well, it's just like UV. There's a ton of energy there, but you can't see it. You know what I mean? It's that.
Well, there's different types of black that happen. Like if stuff falls
You
off,
see it in the round.
right? If stuff falls off the spectrum on either side, you get black too. But the other side of black is on the other side of green as well. And when you're looking at your famous photo that you love to put up there with the this and the that, right? Well, what do you see? And it's like right in the center, it's pink, it's blue, and then it's green in the middle of the pink and the blue thing. But then on the other side of it, where the green is black. And then on where the other stuff is kind of white. Like, I mean, this is like, science doesn't like what we're saying, but this is it, man. Like that's the observation, and it's the observation over.
What you gotta ask yourself one question: why does it keep repeating itself? You see, if you compartmentalize yourself, you'd have a different name for all the same events, right? And that's what happens in physics. But once you see the full picture, you see it correctly. Okay, it's not a whole bunch of different things. It's the same thing. All you're doing is changing size, energy level, okay, compression level. Once you change those three factors, you could change anything, right? But that's what's going on from different size to size to size, is you're changing those factors. That's it. Okay, it doesn't build out any different. It's all the same code. This is what physics doesn't want you to know. Okay, they hate it because then they have to go back and redo all their stuff because they like to compartmentalize themselves with different names. Well, I don't see their bullshit anymore. I don't even call them by their names because it's useless. You know what I mean? Because I don't want to get in an argument over the name of what I'm doing because it's pointless. I don't want to have that kind of discussion. You are absolutely wasting my time in that manner. Find out how it builds and then let's build it. Okay?
All right,
Call it
Nathan,
one name.
Before we fall off the deep end here, I love the simplicity because it's to a person like me, it says so much. But Ian Jackson says simply, ionized oxygen gives off green. Well, there's two parts to this, right? And this is why I absolutely love that you put that. The first part is the green rarefication that happens, okay, in these red blue shift events, okay, is a different green. Okay. Like, and we've seen that different green. It's it's like a toxic crusader green, you know, or something. It's like it's literally dead center spectrum green, or you know, it's insane. But secondly, and this is why it's important, is because what is oxygen's role as a thing in the process? Well, it's the thing that traps hydrogen, okay, and allows the hydrogen interactions with everything else. It is an intermedium, which is exactly what we're saying green is, okay? You have to see the correlation here. All right. Oxygen is the intermedium that breaks down other matter, okay, into oxides and then allows for the fluid reaction with its free hydrogen in solution in water to make hydrogen out of those materials, which is bringing actual material, complex material, from one side on the material side closer to the energy side of hydrogen, because hydrogen is immediately closer to pure energy state, and therefore a dimensional return to an actual pure energy state. Okay, and that's what you have to understand, why it's so significant and proving the point of the intermediate nature of green, that that's what it lights up when it's ionized, because that's exactly its role in chemistry. That's exactly its role in physics chemistry. You know, is this intermedium, you know, between the material and the energy world through hydrogen.
Wow.
Thank you. I like it. And what's the material world? The material world is the infrared spectrum. Why? Because when the two red and blue are separated, you get infrared. And what is infrared? Heat. It's heat. It's heat.
Yeah. No, I agree. Huh, buddy.
No, yeah. The more you talk about it, the more somebody that would like to argue these points would find themselves in a very whole lot of world of trouble, because they would have to contradict everything that they'd argue to me about on this subject, you know, in order to try to prove me wrong, and then they would have to have no integrity at all. Like you would have to turn around to them and be like, so infrared isn't heat then? You know, and they'd be like, well, no, I mean, infrared is heat. Oh, infrared is heat. I see.
That's funny.
Oh, you see.
Yeah. Hey, I want to put this out there, guys. We're getting close to the end. We're almost 3 hours. I know I showed it in the beginning, but I know Ian asked, like, when we did the sensor array and stuff, everything was on the pillars. So what happens is I needed stuff next to the craft, and then I needed stuff further away from where the pillar is and the cameras and stuff, right? I ran it next to the craft, and I was having trouble picking up some of the sensors. So I changed everything around. Okay, and it's taken a while. That's why we're doing this. I want to show this to everybody again. This right here is how we worked it out. Now look, we're creating these in here so that now you just basically take your cord and your sensor and you plug it in, okay? And then you get over to this side and you do the same thing. That's all the camera array right there, right? It goes right into the camera. And then we got the spots for another one and another one, okay? And then we have this that comes up here on the top, and it basically gives us a camera that comes off of here. And then anything that has to sit on top of the camera, okay, for the RF and everything else. Now, it's taken me a while to go through everything. I basically had to go through and write down everything, every schematic that goes on in these things, and then go on and find out what the parts are and what the parts do and cross-reference everything, find out how they work, if they got to go like this or what. You know what I mean? everything in there so that we can figure this out. We are very close to getting everything done. I lined out the oscilloscope last week, went through it, checked it, ran the Tesla coil, made sure that everything matched my oscilloscope. Then when I did it on every single one of the frequencies that goes on, I ran 5 or 6 different frequencies at once in order to clear out the noise and to set the parameters of what it does so that we can eliminate background noise, washing machine going off, or road noise or anything like that. So I have been working through it, and I haven't published much on it. I guess I should, but a lot of this stuff, guys, is just making it simplistic so that plug it in, put the sensor where you want it. So the first thing that we're going to do is just make basically a farm fence and make little beepers that connect onto it. And that's where your sensor is going to be. So you're basically 1, 2 over here. They go to this area. They'll have some that are underneath it, hit to the magnets and stuff, and then the RPMs, things like that, so that they're easier close to it. And then certain things that cannot be next to it because of the voltage have to go in different areas on this, okay? Some of the stuff's going to have to be lined on the inside with aluminum tape in order to make an RF shield on the inside so that we do not get the whole sensor just blowing up, okay? That's what's really cool about this, okay? I wanted to take my time and do it right because you don't get a chance like this very often, okay? So
it's an incredible piece of equipment. It really is, and it's going to be game changing, and it really help out in Tesla tech and everything like that too, because there's going to, there's going to be people with questions that want answers, and
yeah, I'm hoping I got 2 weeks of good runtime before that. That's
all right. Now I know that we're 3 hours in, and I don't want to go off on an hour-long tangent on this, but I want to hurt people's heads. For those that don't know, but sensors are diodes, and so are diodes that emit light. And the thing is that anything that's capable of sensing something, okay, is also capable of emitting the same. All you have to do is run it in reverse, like Gerald used to like to say. And the thing that you really have to realize out of that is there is no such thing, okay, as something that is only a receiver. So when you talk about observer effect and you talk about all these different phenomena like that, what you have to realize is that if you're receiving energy or light or whatever, like let's say into your eyes are also capable of putting out exactly the same in which it's capable of taking in when run in reverse. So there's no such thing as a pure state of emission or a pure state of observation. Either are simply interchangeable versions of the same as an antenna. There's no such thing as only a receiver antenna. You see, an antenna to a specific signal is just as capable of broadcasting as it is receiving that same signal. Okay, it works inversely through an exchange process. And if it's capable of taking it in, it's also capable of emitting it out. It's a capability circumstance that occurs.
Dude, Superman eyes, here I come. You know what I mean?
And it's really mind-bending when you think about it that way, that all the light that comes from any given star in the sky that reaches your pupil is pretty much reflecting that exact same amount of light right back to the source where it came from. And how fast? At the speed of light? Well, what did we talk about earlier? Well, that's only a dimensional fucking threshold. That's a dimensional restriction. That's all that is. That means that instantaneously, it really will bend your mind when you get down to the meat and potatoes of all this stuff. And actually it should scare the fuck out of you too, because every time you're sitting there, like looking at your phone, for instance, which is putting out light, well, there could just be something running in the background sitting there taking you all in as a camera and a feed.
That's also why your eyes hurt. There's too much reflection of light between you. Yeah.
between
But
the
yeah,
two.
there could be all kinds of stuff going on in the background, like subliminal messages. Remember those when you went out to go to the theater and they'd show Coca-Cola in like a one frame, and then you'd be like, "Oh man, I'm thirsty for a Coke." So it's kind of like that in the background of your phone. They're probably programming us all to be stupid.
They could do really anything, and that's the power of it all. Is that it could be broadcast this way, but also like your eyes connected to something else that processes all this information, that then is connected to all this other stuff. So you could let that run in your mind for a moment and you know start to realize very quickly that anything that emits light could also be receiving in all intelligible information that you're aware of,
Oh
you know,
yeah,
consciously and subconsciously at any given time. So everything in the world that emits light turns into a circumstance, or sound for that matter, turns into a circumstance where it becomes that critical sphere. Everything. It's just then returns that information. All the information, what's done in the dark is brought to the light, right? Like you could defeat the fact that maybe there's light, but you can't defeat the fact that there's sound.
yeah.
Nope.
Well, they try to tell you there's no sound in space. That's one of the dumbest things I've ever heard.
Yeah. Well, if there's matter in space, then there's sound in space.
Well, yeah. I mean, look,
They're trying to say that there's no sound propagation because it can't create a pressure wave through the vacuum. Is like that's their argument. I get it, but I hate to say it, like that's
well,
not how sound works either.
the satellites flat out told them they're dumbasses because their satellites go out there and pick up all the signals coming, and they hear
Yeah.
all the noises of space and everything else. And it's like, okay, if there's no sound in space, how do we have noise in space? What the hell's going on? Why do you have solar wind?
Well, we've been listening through
Yeah.
what? How?
Yeah, I mean, seriously, it's
And,
like
and that which receives, hold on, follow the same logic. That which receives is also capable of giving, right? So when they're listening for these sounds in space, how are you supposed to reach out somewhere distant and pull a sound from somewhere, because it can't be transient through the vacuum? That I mean, listen.
Look, hold on. They say no water in space, right? I guess transpermia's out. That whole concept is gone if there's no water in space. Why does the space station have like barnacles growing on the outside of it? I don't know. Maybe because there's water in space still. I mean, they say there's no air in space, but that's not exactly true either. Look, they are what sometimes people say is stupid. It reality is much different than what they try to make it is. In your experiment, it shows it's not there because your experiment isn't reality. It's a separate thing altogether because you suck out everything special instead of converting it. You literally ruined everything by putting that big vacuum chamber on it, and you don't even realize it.
When there's no matter in space, space doesn't matter. You see what I mean? So realistically, all the perceived gaps in between are just that, they're perceived. You know, if there's nothing in between, then there's nothing. And if there's nothing to observe, then it doesn't exist. So, say what you want. I mean, realistically, I think I'm starting to believe more and more as time goes on that space is so much fucking weirder than anything that we're conceiving of. We probably are the center of fucking everything, to be real. And I think science is actually falling in line with that, which is strange. But
I don't agree with that at all. But go ahead.
Well, I mean, and I'm starting to believe that there's a good possibility that realistically, when you hear out, you're really hearing kind of in and out in like some kind of fucking holographic mirror spectacle with probabilities. Like, I kind of think that's what might be going on. I think it's pretty strange, man.
They have cosmonaut mirrors or something going on. You know what I mean? They're starting to get into seeing the future and the past and shit.
I mean, like they say it's infinite, it goes on and on and on. It's arranged in all these ways where it's condensed and then spreads apart and then voids and then condensed and spreads apart and then voids. And then miraculously, our galaxy exists basically in a fucking void. And you look outward and it's like all this other stuff. It's sort of like everything else is breaking off from us, and you could just look through time and just see all the shit that did and didn't happen you know
No, hold on. I
like and
see.
in infinite ways, like you know what I mean. It's kind of crazy to think. Like, I don't know, man. I don't think that there's like I think that I'm starting to believe. I'm not saying I think. I'm starting to believe that it's just stranger than just physical
See,
material floating out there somewhere, man. I think it has something to do with holograms and reflections and past and present. I don't think it has much to do with material at all.
I disagree because I saw the way the RAV works and the way that it takes and focuses light, and it'll shoot out a beam of light, hit something, and create this total environment inside of it. Okay. So when you think about how the solar system is, it's exactly that. It's a beam of light hit us and created the environment and is instantly established the speed of light inside of it. So does it come out in different areas in different ways doing the same thing? Absolutely. So I think it's a series of bubbles running around, which is just basically solar systems. And you know what? I think they're everywhere. I do not think that we're the center of everything. I think the center is more mysterious than everything. It's a gigantic freaking rab that has no way of understanding how the hell it came into existence.
Yeah, I mean, I don't say that like the whole we're in the center of everything is some kind of like earthling complex narcissistic fucking bullshit. Like I say it because there's like this real fractal circumstance, um, probability, chance, and choice that occurs, and a real definite reflection, refraction circumstance that occurs, and the condensation of it all, like in the middle of pressure centers, and I just think that it would actually be plausible, at least plausible to think that we think about like this multiverse situation, this, that, the other thing. What happens when you realize that the multiverse is actually where you've been all along, and realistically, just all the probabilities, all the things that happen, everything, whatever, it's just all around you. It's all around you. It seems far away, but that's because it broke off. Reflections of chance and shit, all the possible different arrangements. It's why they can't even estimate how many stars there are or how many galaxies there are, let alone how many stars there are, let alone how many planets there are. I mean, if you think about it, if you look at a much smaller reality and then you were to break that into all the probabilities that could have been, and then you start scattering them out, you realize quickly you'd never be able to count that either, and it would seem infinite.
Got it.
And who's to say that that's not the case? Like, would it be strange if you peer out to what you think is like the cusp of reality, and you somehow were able to observe like some kind of verifiable probability that occurred locally? I mean, like it might sound real strange, but they'll like real scientists will tell you that the probability of somebody right now that looks like me saying the same exact thing as me, it definitely occurred. you know so I mean, how is that? You see what I mean? Except in a slightly different way, said it in a
Yeah.
slightly different way. And then that broke off from reality, and that's somewhere. And if you were to put your eyes on it, you'd be like, oh, what the fuck? You'd see it and it'd be a reflection. You know what I mean? And that's all it is. That's the whole point. It's just that simple. Maybe.
I have to see it to believe it. Sounds strange. But then again, everything sounds strange until it happens.
Yeah.
We'll see.
It's crazy. That's like the most unverifiable thing ever, right? So.
Right on. All right, Joe. Let's call it a night, man. I need to get out and get something to eat real quick.
Right on.
I want to say thank you to you, Ulysses, out there, brother. Thank you very much, man. I appreciate it. And I want to thank everybody in the chat, man. Shout out Lightspeed, man, for hooking us up with this whole system. And hopefully we'll be doing some results here real quick. Like I said, I need a good run before Tesla Tech, man. And Tesla Tech's coming up next month on the 12th. And then also tonight I'll be on Traveling Fools. We're going to be talking movies and horror movies. And it'll be a fun show. Anyway, with that said, guys, man, I had a great time today, man. And Crypto, thank you very much for popping in, man, and sharing what you got going on. And hopefully you do it some more, man, before Tesla Tech.
Right on. And I'm hoping for the best experiments to come out and be shown there, and really show that this is like this has been known from the beginning of time, and it's just simply been buried. It's literally God's gift to us, is this wonderful reality. And it's just hard to believe that we've come so far, proved so much, and just like feels like sometimes we're talking to the best people on earth that come and watch us every week, and cinder blocks.
Well, we're making progress, Joe. We hit past 10,000, so we're doing something right.
Right on, dude.
So
it's been a long go. We've been at it for over 2 years now.
Yeah. Right on. All right, everybody. Have a great night.
All right. Peace and love.
Oh, hold on.
Oh,
Almost forgot.
That was at it.
The old man builds. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.